Hello and welcome to the Automation Village Virtual Trade Show. I'm Dave Spencer, and joining me today as our correspondent from a social distance will be Chris Little. I'm just going to bring Chris Little on right now. So if you see me looking down at the console here, I'm in the studio by myself today. So I'll be doing a little bit of up and down work as I bring people in and out. So you've got Chris Little on right now.
Hi there. I'm coming to you live from the fort in my living room. You can't see it, but I've got a green screen right now that, depending on when the light changes, you'll be able to see holes through the space-time. So don't be alarmed.
Things at the trade show are looking great behind you, Chris. It looks a little slow. Things are moving slowly, but other than that, it looks wonderful. So we're talking a little bit, Chris, about kind of simulating the trade show experience. So in the virtual trade show today, we're going to be bringing you roughly a dozen presentations. We've got a lot of different things queued up for you. And part of that is going to be kind of trying to recreate what people would experience if they were at a trade show, right?
It's true. I mean, well, obviously you're here because your organization has put aside time and resources for you to go out and learn things and meet people and find solutions. So we're trying to recreate each of those things in this kind of an experience. So you want to, part of it is just to get out of your everyday. So we're hoping to provide a little bit of that, get out of your context. I guess we're all out of our context right now. The other thing is to make connections. So over the course of today, we're going to meet, I can't even remember the final number. Is it 9 or 10, Dave? Different experts in the field. And they're going to each give a high-level presentation, kind of like a TED Talk, trade show TED Talk, kind of like a TRED Talk. And and each of them are going to be around after the show or during the show. They're going to be in the live stream. Natasha, who's going to be looking at the live stream, is going to be directing people to people's websites where they have live chat and that kind of thing. So hopefully we'll be able to recreate, actually be able to put you in touch with people that you can actually chat back and forth with and ask real questions.
Right, that's fantastic, Chris. Yeah, so as you noted, we do have a number of presenters. We've got a lot going on today. So, Chris, our first up, we've got a presentation by the president of Trihedral Engineering, correct?
You are correct, and I just put up his slide now. Glenn, I think I need to, oh, he's unmuted already. Hi, Glenn, are you there?
I am.
Good morning, how are you?
I'm doing great, and as well as I can be from not meeting with anyone else. But I thought I'd take this opportunity to just welcome everyone. Thank you for coming back. If you visited us before at the virtual trade show, and welcome to those that are first time around. I hope you get out of this what we hope you do. So one of the things I wanted to talk about this morning is, as you probably know, that VTScada at the core is built around a scripting language that we've developed for the product. And one of the questions that you sometimes get asked is, why do you create your own language? So I want to go back to where this all came from, the genesis of this kind of idea. So our experience, when I came out of university, I worked for a company that developed SCADA systems. Actually, they hired me to write SCADA systems on these new PCs. And the idea was to use a PC. So I wrote some software in BASIC and Pascal for various cities and found that it was a very time-consuming problem, and decided that we needed to create a tool set for this. And then I said, well, how would we create a tool set? And they said, no, I don't think we want to invest in that. So I started Trihedral. And I said, why create a language? Well, we needed something, at least when I thought about this problem, we need something at least to do expressions. So we need some sort of language. And doing anything else, some sort of language to look at, there was nothing out there to meet the requirements that I had. So I just want to talk about where these requirements came from. So looking at scalability is one of the things that I had thought or learned from doing these bespoke projects at the first company I worked for. Things needed to be able to scale up well. There was a lot happening in a live control system or SCADA system. So one of the things I learned working in my graduate degree at the University of Minnesota, I had a project given to me by my mentor that was to try to solve a problem with working out test cases for integrated circuits. There are some of these integrated circuits being created by companies like Intel were so complicated that if you applied every possible input to this, you were not going to find or not have enough time before the sun turned into a red giant to solve or test every possible input case. So the idea was to create some sort of reduction of tests that you could actually be sure you covered all the test cases. And it was introduced to an algorithm or a paper that had this idea of a event-driven scheme. And that created this idea that you really only need to have in these control systems, that when something changed, you only really needed to execute something that depended upon that and not everything in the loop. When you do the bespoke kind of projects, you would have to basically refresh all the I/O, then refresh all the data logging, then refresh all the pages. And you do everything all the time in a loop, and that wasn't going to scale well. So we created this event-driven programming paradigm, which became the VTScada programming language. It's now known as a reactive programming language. It's a style of programming that's not that common. Google actually cites the invention of this in 1997, but the first version of VTScada using that was in 1984. So we're pretty well trailblazers in that. And there's some big companies using it, but a small, like Facebook uses this model as well. So that was one of the big things what drove the language. There was nothing else out there like that, and we needed something also that fit the problem. We're dealing with drivers and pump controllers and things that had multiple states of operation. And when you're trying to do that in a procedural language like C or BASIC, it becomes quite a challenge to get that right. And so we needed to do something that I also learned in university, this state logic paradigm, where you're in a send state or receive state, or the pump's in the lead position or the standby position. It's an alarm or not an alarm. There are states of operations, and the behavior in different states changes. So you needed a way to handle that easily. So that was one of the driving criteria of the VTScada scripting language. Also on this whole game, we figured out that when you're dealing with live systems, 24/7 operation is essential. You just don't shut down the plant because you need to do an upgrade or even a configuration change. So one of the driving forces of this, we needed to be able to change the code while it's running. And that's quite a challenge for our programming language. So we built that into the system, and that's one of the key features of VTScada. Another part of the problem is with extensibility. I want to describe kind of the two approaches to extensibility. And what I mean by extensibility is that customers need to be able to add their own custom logic, custom capabilities, change the way it operates to meet their particular requirements. And the common way that's handled is with what we call hooks. So that a hook would be something along the line of an alarm comes in and you want to do some additional processing on that in addition to what's already done. So it's a way of handling or doing additional things beyond the core product. But I want to take that a step further and said, I don't want just a hook. I want to be able to replace the way the core product operates. So you want to override the core product without just adding capability to it. So if the core product doesn't do what you want, you could change that without modifying the core product. And that's a key piece. We came up with this idea of late binding, which means that the core product is what it is, but you can add pieces to replace core product components and make those do what you want it to do instead of what the core does. So that's a key piece of the product as well. So we've got scalability, fit for the problem domain. You'd be able to change without restarting the code. We need to make it extensible. And my last point on this is we need to make it forward compatible. Now, there are, I think last count, something like 700 different programming languages. And just look this back at why do you need one of your own? Well, to outline why we need one of their own. It's there's nothing out there that matches those first four. Forward compatible is one of those ones that are really important. When I started writing the code for this, it was written in Pascal or Basic when I was writing bespoke versions for my former company. I said, well, that's really, I thought this was going to be around for a few years, and you don't know when a different language will come along or a language will be obsoleted. So I don't think anybody's writing in COBOL anymore or Fortran, which were still around when I started. But C was there, but it was a new language at the time. So we wanted something that's going to be around and maintainable. So we wanted something what we call forward compatible, something that we want to be around for the long haul. And the way we make that happen is that we can write a language where it then becomes something that we can maintain and enhance. So today we can create code, but code that we wrote 20 years ago will still run today. So it's forward compatible, that you do something today, it's going to work in the future. That's a key part of the whole compatibility problem. So it seems like an odd approach to write your own programming language, but it solves a whole handful of problems which you could not really solve otherwise. So I think we're the only company in the business that has done this. We actually have almost all the core components, all the drivers, all the communications, all the historian, all the graphic screens are all done with the scripting language. When you do graphical configuration with the Idea Studio, you're actually generating code in the background in VTScada. And there's a button on the Idea Studio which will allow you to open up and view that code if you want to and modify it directly. So there's a lot of power in that code. Now, this language continues to grow. Right now we have over 700 functions built into the language, and we keep building on these. We have people that are building code as we speak, enhancing it. We've added features, making performance better. So there's always something new in VTScada at the engine level. But that engine level, which we call the language interpreter, is something that's an evolving piece, but it's always backward compatible. So that's all I have to say for this morning, and enjoy the show.
That's great, Glenn. That's I remember a very similar story happening more recently when we developed. Well, I didn't develop it. When you created version control, which we're going to talk about a little later, there was a lot of research into what kind of version control will we adopt to put into VTScada, and the answer was the same. No, we have to build our own from the ground up, and I think that's. When we talk about that later, we'll see how that philosophy also pays off for us going forward. Thanks, Glenn. Thanks for that.
Thanks, Chris.
Talk to you soon. So now, we didn't talk about this off the top, but for those of you who are wondering whether you should stick around, you should stick around because we have prize giveaways, although I guess they are technically games of skill.
Right.
Do you want to read a few of the rules there, Dave?
Sure. Yeah. I think the first one is that where it is a game of skill, basically we're going to give you a code and you're going to email that code out to Natasha. And you see the email on the screen there. When it comes down to prize time, the information will be up on the screen. Basically one entry per participant per hour, and we're not going to have necessarily more contests than that. I think we've got, is it 5 draws today, Chris? Or
That's correct.
So yeah, so we're going to be putting these in kind of slightly sporadically, and we're going to go from there.
All right, so stay tuned and have your email ready and ready to go. Okay. So I think that's you and I talking. So now we are going to go to Ian Clark, who is one of the partners with Quintessential Services. Ian, are you there?
I'm Chris. How are you?
I'm good. Thanks for joining us today. How's the weather where you are?
Oh, pretty good. Not too bad at all. That's not my picture, by the way, but hey. That's different Ian Clark. That's all right, though. I'll be that guy today.
Excellent. If you would, I'd appreciate it. That's great. And you're looking pretty good. I like that. I hope you at least have a jacket like that.
Thanks. Yeah, I'm full suit.
Whereabouts are you located? Where is the weather where you are today?
So we're located in Calgary, Alberta. So it's, southern Alberta is where we're at. And the weather's nice today. No snow, which is good for spring, at least around here.
That is good. So how is your company adapting to the reality of working from home? What kinds of tools or skills or strategies are working for you right now?
I think we're pretty lucky in terms of how we do our work. We found the shift to working from home pretty seamless because our entire virtual world is pretty much accessible from anywhere with power and an internet connection. So it's not really that big of a deal.
Right.
I guess the collective nature of our business in SCADA and automation is by definition something that must work remotely.
Right.
So I suppose that's been a part of the reason why the impact has been fairly negligible.
Excellent. That's great. So just moving forward here, now you're going to be talking about quantum EFM, and that is another example in the larger pantheon of monitoring solutions out there in the automation world. Where does quantum EFM fit into this spectrum?
So quantum EFM is a system that sits just above where your data collection assets are. So on the left side of the screen here, you'll see VTScada, ABB SCADA Vantage, and a bunch of other different data sources that we typically see on SCADA projects. Quantum EFM sits on top of all of that, and its primary purpose is to make sure that errors in measurement data do not proliferate through the organization, because as they move up the value chain, they tend to become bigger and more problematic. So the idea behind quantum EFM is to give a first pass over that data and make sure that the stuff that you're sending to your accounting systems and so forth is decent quality data, so you don't have those problems downstream. Okay, so as far as features go, time-effective configuration and a comprehensive audit trail are really important on a system like this. You need to be able to say that with accuracy that the data that you've messed with is indeed the right value, and you can always go back to the original value. So this in Alberta, this is called Directive 17 compliance, where we have the ability to be able to prove how we changed the data or didn't, as the case may be. Metric imperial support, so units again and measurement are very important. We sometimes receive imperial data or U.S. customer unit support, but we're storing it in metric, that kind of thing. So be able to move back and forth between those unit systems is really important. Intuitive oil and gas and wastewater configuration. So different kinds of metering for different industries. So oil and gas, you're obviously dealing with liquid and gas meters versus water, where you might be dealing with a pH meter or an O2 sensor. Scalable and configurable data acquisition. So quantum EFM itself doesn't really have a polling driver. It relies on systems like VTScada, like AutoSol, like SCADA Vantage to provide the data that it requires. As far as enterprise integration goes, enterprise security and Windows Active Directory authentication is also something that's fairly important these days. And then, of course, active display management. So like VTScada, if data changes in quantum EFM, it is pushed out to all clients that care about the data, and you don't have to refresh. So that's a fairly unique thing in a business application, because that's usually more of a SCADA DCS thing. Okay, next one. So at the core, quantum EFM represents electronic flow measurement data. So these are records that you would get from a metering data source, such as an RTU or a flow computer. So validation profiles can be set up to go against this data, and then the data is validated as it comes in. So what you see on the screen here, those blue boxes indicate frozen values where the value is not changing enough for it to be considered changing based on the way the telemetry profile is set up. You also see examples of edits that have occurred here, and then the ability to also sprinkle in your alarms and your events from your Directive 17 compliant data source to be able to provide context for those edits and justification for why you made them. Okay, next slide. So process value reporting on SCADA projects, we sometimes, more often than not, see requirements where we've got to move, a random piece of analog data from the SCADA system all the way up to the production accounting systems. And the process value reporting essentially allows us to do that. It's similar to, in concept, to an OPC tag, in that you can pull a history from a data source. So we can go after OPC tags, we can go after the VTScada historian, pull in this information, and then organize it in a way that can be published downstream. And there's multiple different publishing vectors we support: copying to file systems, FTP, emails, the works. So this is kind of a a way of us not being out having to write custom code on every single project. We can just configure this system to do that. Okay, next slide, please. So product quality management, measurement data is only as good as the quality information that comes along with it. So if you don't have decent lab analysis data or chromatograph data to support things like a supercompressibility calculation or an energy calculation in your RTU or in your host, your measurement data is essentially no good. So the idea behind this is we can accept information from lab analysis, online chromatographs, or even in some cases, you've got a PLC that's calculating a blended analysis. We often see this in the enhanced oil production or CO2 production type environments. That information comes into Quantum EFM. It is also subject to validation and editing, and then it can be distributed to any field devices which require this information to do their flow calculations correctly. Okay. Tank inventory management. So this is the ability to represent tanks of various geometries. So you could have like a bullet, a cylindrical tank, a spherical tank, that kind of stuff. In practice though, most tanks are what we call strap tanks. So they have a certain level. As you go up the tank, there's a certain volume that's inferred by that level. So when you get your tank strapped, you essentially get a CSV file or an Excel file that says, okay, we strapped your tank, here's how much volume is in it. The ability then to represent that as a gross volume and a net volume is something that Quantum EFM can calculate, along with the ability to track load and unload information. So these are often referred to as tank tickets or truck tickets. They're essentially transactions against the tank where you're putting stuff in or you're getting stuff out. And again, they need to be validated. They need to be pushed downstream to other accounting systems so that the entire facility or entire area that you're working with balances. So that's the idea behind tank inventory management. Well test management is a similar thing, except in this case, what we're talking about is accurate well test information. So when you have a bunch of wells in the field that are producing, you put them on test. Which means you flow them into a separator and then you measure the amounts of gas volume or gas, oil, and water that you get out of that test. That information is then used to prorate production back to individual wells from a group meter type situation. Again, this stuff is pretty common in the oil and gas industry, and it needs to be validated. It needs to be correct, because if it's not, your interest ownership back to your wells and eventually how people get paid could be affected by that. Emission monitoring, this is something that's not going away anytime soon. We're finding that in industry, the requirement to report emissions, and to have the ability to say, we are tracking this stuff is super important. CEM's continuous emission monitoring system tracks high resolution data with respect to flare temperatures and a few other parameters. And this information is used for regulatory compliance. And in some cases, it's required for a given facility's permit to operate. Next one, please. Okay, so on the regulatory front, in Canada, we have an organization called Petronex, and they are essentially Canada's petroleum information network. So once all of your information has gone through your accounting systems, it eventually has to go to the government so you can report on production, you can report on a number of things with respect to your operations. So dealing with Petronex it's something that companies just have to do. And the ability to download and validate information from Petronex can be a big help when it comes to dealing with your regulatory compliance concerns. So the main plus with support here is we can download the workflow items, which are essentially to-do lists between industry and the regulator of things they need to be compliant with. Those workflows typically have due dates on them, and if you miss them, that can become a real dollar type risk to a penalty and that kind of thing. So the idea with the Petronex support we have in Quantum EFM is to be able to avoid that and be proactive in addressing some of these issues. Okay. This slide here concerns one stop for data rectification. So what this drives home is you've got all of this data coming in, you've got all of this validation going on. This facility within Quantum EFM provides you a one-stop shop to be able to look at any of the problems that the system has flagged across different asset classes. So again, we have metering, gas analysis, tanking, wells, Petronex, and any others that we require. For example, a plant facility balance might be in there. And now we've got the ability to look at all of our problems in one spot. We can double click on any of those rows and drive into the actual flow editors that deal with whatever it is that we're looking at, and then we can correct the issue. So that prior slide was data quality, so the actual data itself. Conflict and missing data detection is another important part of validating measurement data. So with conflicts, what we term those is you might have, for example, an RTU in the field which maintains 35 days of history, and that's all it can retain. Quite often what we'll see is if that RTU fails or the power goes out, whatever the case may be, the clock will reset and you'll start getting data in the past, way in the past. And so the idea there is to be able to track that information. The measurement data is still good, it's just off in time. Down at the bottom there, missing data. So again, not knowing what you don't know. So we need to be able to track whether or not we have actually received data for a given set of assets. And the system will do that as well. So Chris, thank you very much.
That's great.
I really appreciate your time. And
thank you, Ian. And just wanted to say, of course, we saw VTScada as one of the various platforms that connect to your system. Can you tell us a little bit about the value in that relationship, specifically between a SCADA platform and Quantum EFM?
Yes, very much so. So VTScada was it was the first platform that we integrated with Quantum EFM with. It has really tight integration with the oil and gas layer and with the historian and with OPC. So all three of those mechanisms from VTScada provide a really good, solid source of data for Quantum EFM to add its value. So we really see Quantum EFM as very much a complementary offering to VTScada, and it's made a lot of the projects that we've rolled out with VTScada be quite a success as a result.
I'm glad to hear that. That's great. So thank you for putting up here. We see some ways that we can get in touch with you. People can go to your site, write you. If they've got anything they should know before they contact you, anything that they should have, any ducks they should have in a row?
Not at all. No, if somebody wants a demo or they just want to talk about whatever problems they may be facing, they can email us at that sales@quintessentialcomputing.com, and we'll take it from there.
Excellent. Thanks, Ian. Thanks for joining us today.
All right. Thank you very much.
All right. Now it's time to win.
Contest time.
Get your phone, so your email devices out.
Right.
So
this is for a $100 online shopping voucher, and the magic. So the subject, what you want to put is VTScada scripting course, exactly how you see it there, and you're going to email that to Natasha Lutz at trihedral.com, just exactly as you see it. So you'll note the I in Natasha, and you say. So that will be open just for a short while, and like I said,
all uppercase, by the way.
We've got a number more of these coming up. So so
that's some big money.
Yeah,
so all the rules are written down there if you've got your reading glasses on. Otherwise, you can click on the link and go to our website and read them all there.
Very good. So, Chris, while people are doing that, we've got some other content coming up.
Yes, we've got cybersecurity with Dispel. They were at our VTScada Fest a few weeks ago. That was great. And we also have virtual commissioning with EN Automation. And that's a great presentation as well.
Right, very cool.
And very relevant to today's work environment.
Right. No, that's awesome. So I guess we should probably move things along. I've got you up in my kind of panel role here. So did you want to go into the presentation with Dispel?
Yeah, let's do that. Oh, here's a picture. There we are. So let me just see here. Ian Schmertzler should now be. Hi, Ian. Are you there? I see he's there.
So we'll give Ian a minute to get his audio connected.
I think I need to allow him to talk. My mistake. Hi, Ian. How are you?
I'm well. How are you?
There you are. You were just screaming into your microphone a second ago, I'm sure.
Oh, par for the course.
So I hear you're also coming to us live from the fort in your living room.
I am. I have taken every blanket, towel, and other soft object and placed it over every hard surface in my house. Like most people who work in tech, this seems to be the way life has moved forward.
High tech is low tech. So where are you coming from today?
Austin, Texas.
Excellent. I love Austin. And now you were at our VTScada Fest, and you did a really high energy presentation that I really enjoyed, and a really nice style. So I'm looking forward to seeing that today. Dave, are you ready to roll?
Yep. So we'll just roll into Ian's presentation.
Let me tell you a story. The scene is a water utility, and what they measure there is what they care about: uptime, availability, and safety. Our protagonists in this tale, that would be our heroes, consist of two characters working at the water utility. The first is an operator, the second is a cybersecurity specialist. They do not like each other. We're going to talk about the operator first. The operator's job is to maximize the uptime, availability, and safety of physical systems. They used to do this very quickly and very well. But how are they valued now? Not based upon how they do their job, but based upon how long everything they have to do to fix those physical systems takes. And thus enters our villain, the intermediate step. Now that used to be, I need to fly out to the job site, or I need to drive out to the job site. These were readily relatable to other people's experiences. But these days, it's mostly, well, I need to remotely access the industrial control system. And that's a problem, because for most people, remote access means just log in. But that is not the case when dealing with a system built with cybersecurity in mind for industrial control systems. Rather, the operator first must VPN to the corporate network. Well, that's an intermediate step. Then they need to go to a jump host on the corporate network. That's another intermediate step. Then they need to go to a jump host on the SCADA cluster. That's another intermediate step. And finally, they need to perform an RDP connection from that jump host down to the asset cluster. That's another intermediate step. Connecting to industrial control systems built by people who care about cybersecurity tends to take between 12 and 15 minutes to go through. Now that is madness. It's negatively impacting uptime, availability, and safety across the water utility, and it's making the operator look slow at their job. This is also wrong because the operator's time should matter. So our hero goes on a journey, and on that journey they find Dispel, a company that does have faults, like letting an engineer write and deliver a presentation unsupervised, but it's very well liked in the water industry by the people who both service water utilities and water utilities themselves. The reason for this is they offer a secure remote access product that connects in under 20 seconds. It deploys in under 4 hours, and it costs, so long as you aren't doing anything crazy, about $25,000 per year, which is between $25,000 and $185,000 cheaper than the system being replaced. So our hero hatches a plan to bring back one of these systems and to prove its success, thus improving uptime, availability, and safety, vanquishing the intermediate steps, and letting our hero be measured by the job they were hired to do, not those intermediate steps. Thus brings us to our intermission, and then Act 2, where we meet our other hero, the cybersecurity specialist. Now they built those intermediate steps, and they did it for a reason. You see, for lack of an alternative option, cybersecurity has long been an exercise in building castles. And as time and money allow, you add additional walls or you improve the ones you already have. This strategy is called static defense, and our hero knows that he needs to use it. When dealing with remote access, most of the world sees remote access as, well, A and B are talking about something, and that traffic stream is what's important. So they say, use a VPN. Between A and B, your job will be done. But when you're dealing with remote access to an industrial control system, the attacker doesn't care about the traffic stream. What they care about is finding A or B to launch an attack directly against those systems. And when you're dealing with a larger industrial control system, it doesn't look like this. It looks like this. So it's very easy to find the target of value. Now, what this means is that whilst our operator thinks they're seeing a bunch of intermediate steps that are getting in the way of them doing their job properly, and thus results in them calling downstairs to the cybersecurity specialist and saying, my time should matter, from the cybersecurity specialist's point of view, those are walls, not intermediate steps. And that's a static defensive structure. The real problem of late for our cybersecurity hero is not the yelling. It's that the cybersecurity structure that he's using isn't working anymore. You see, static defenses fell out of fashion in the physical world because castles do not move. They're easy to find, and unless you are constantly and correctly anticipating the types of attacks that will be launched against you, and then both building those defenses in time and implementing them across your organization, someone will find you, analyze you, work the problem, and punch a hole through. The same is true in cyberspace. So, the static defenses that are out there are beginning to break. Now, there is an answer that our hero knows about. It's been around for about 12 years, and it's called moving target defense. The way moving target defense works, unlike static defense, is instead of putting the thing that you care about into the middle of a big fort, what you do is you put it into a vehicle and move it around, ideally in a medium where it is very difficult to be followed. This strategy, moving target defense, started to be done by hand in the late part of 2008, and since then has expanded to being something of a commercial available product. So our hero prepares for a journey to find one of the commercial offerings of moving target defense, and instead is interrupted by the operator entering on stage right. The operator says, check this out. So my field network's over there on the right, I'm on the left. All I need to do is go to this console, I'm given a workstation with VTScada on it, and bang, I am in the system. Wow, says the cybersecurity specialist, that's very cool. How can that possibly be secure? Enter the network diagram on stage left. Oh, says the cybersecurity specialist, I get it. This isn't just a set of components, this is a system. And these components were built to talk to one another and work with one another without presenting themselves to you. Yeah, says the operator. So, says the cybersecurity specialist, this is segmented, it's recorded, it's temporary, and it's reliable. Yeah, says the operations guy. More fundamentally, says the cybersecurity specialist, this is a commercial implementation of moving target defense. So our heroes band together to deploy this system, which takes under 4 hours, and vanquish the intermediate steps that were driving the operator crazy. The result is that uptime, availability, and safety across the firm improve. Static defense is replaced with moving target defense, and if it's anything like Connecticut Water, our friends see their firm enjoy nearly $1 million in savings in time alone in the first year of use. Time does actually matter, it turns out. And, surprisingly, operations and cyber are finally getting along. The end. Now, why did I tell you that story? Well, did either of those characters sound like you? If yes, try to spell, or book a briefing with us. Thank you.
And we're back.
Thanks,
Hello.
Ian. That was great. Or at least I assume it was great. I actually couldn't see it because at the very last minute, we asked you to take your presentation and make it into a video. And thank you for turning that around so quickly.
Thank you very much for being so accommodating.
So is that ability to generate, to do high-end video production something that your company is having to accelerate these days?
One might say that was an antibody developed as a result of the coronavirus.
True
Yes.
enough. So for the people who looked at that video and went, yeah, that's I need to know more about this. Obviously, they're going to go to your website, which you showed us, and also is listed in the comments. All of the presenters will be in the comments of the live stream. What are the things that they need to think about before they call you?
Usually they need to determine which one of those two characters they are. If they're in IT security, they're going to have a set of questions that inevitably they'd like to ask. They should feel free to ask them all. If they're in operations, but they haven't been in the field for a bit, I'd suggest they go out and talk to their team, because usually what ends up happening is it turns out there's not just one particular way people are interacting with their systems. It's good to get knowledgeable about that before you show up, because then you'll get better advice on what to do.
Gotcha. And what is it for a lot of the people who don't want to make that call? What are the barriers that are keeping people from changing what business as usual?
It's one of three things. First, it is concern about whether or not they can navigate the institution that they are a part of. And usually they'll find out that IT people are very friendly people if you just go and talk to them and don't throw things at them. The second thing that frequently is happening is it's a lack of it's a suspicion that user interfaces haven't evolved beyond a certain level, and many have. So if you can find something that is as easy to use as an iPhone, for example, well, then maybe you don't need to be using a laptop anymore.
Right. And so when you were creating this presentation, I understand that you actually had to change up your approach at the last minute. What was driving that decision?
Now that was an evolution as well from the coronavirus. What happens when you are all placed at home is you start to read lots of books, not least of which you read a lot of comedies, and you come to realize that there's a common theme in how stories are told. And when one's giving a presentation and explaining what one is doing, why not have a lark and try and make it more akin to what a story would be like?
Right. Well, that's great. Anything else that you'd like to add? Any advice that you'd have for people who are about to begin this journey?
My advice would be is if you're using VTScada right now and you are enjoying it, but there's that moment where you see something on fire in the distance and you realize you're not able to connect to it, that's when you should call Dispel. But otherwise, if you're using VTScada and you are enjoying it, well, you've made the right first decision anyways.
Great, thanks, Ian. And again, you shared with us, I believe, at the end of your presentation, how to get in contact with you. Your email address, your web address is down in the comments. And if you've got any questions, Ian's a great guy. Again, we've had some experience recently, and I highly recommend reaching out to Dispel.
Thank you very much, guys.
Thanks for joining us. And next up, we have Mark Edelman. Now, just let me tap my head and rub my belly at the same time. I just want to make sure that Mark is able to speak. Hi, Mark. Can you hear us?
Yes. Good morning, Chris. How are you?
I'm good. Thanks for tuning in today. And why don't you tell us, where are you?
I am in Chicago, Illinois, or a suburb of Chicago, which is where our company is headquartered. So.
Gotcha. So do you ever come in contact with Dan, our salesperson in Chicago?
Yeah, we've actually had a number of conversations. I actually just got introduced to him probably about a month ago. And
oh, that's great.
Been able to help set up some training for us. So.
Oh, that's great.
And
he's got some really cool training stuff that he does in the cloud.
Yeah, and we're hoping to work with VTScada and with Dan to pursue some opportunities here in the near future. So.
That's great. So I'm just going to advance the slide here. So you're going to talk to us about virtual commissioning, which seems like exactly the right topic for our time. Tell us what brought you to this decision.
Well, and I'll get into the process a little bit more in a moment. I'll kind of explain some of the reasons, but
yeah,
it's a methodology that we at EN Automation have developed and implemented. And as you mentioned, given the current situation, we feel like this could be a really useful tool for our clients to help them kind of mitigate some of the restrictions on travel and access that we're currently under. I will say that this isn't something that we just rolled out. We started working on this process back in 2015 and kind of fully implement it with the client I'm going to be talking about in 2017. So it's something that we have been doing for a while and gotten, we feel, pretty good at and pretty efficient at. So if you could advance the slide, please. So before we get into a discussion of virtual commissioning, I just want to tell you a little bit about EN Automation, who we are and what we do. We're one of the largest systems integrators in the nation. We serve primarily the utility, pipeline, water, manufacturing, refining, and food and beverage segments. We have over 150 people on our automation team. We support just about every PLC and HMI platform that's currently out there. We are a division of EN Engineering, which is a full-service engineering and consulting firm with 1,800 employees, and we have more than 30 offices across North America. And their primary focus is pipeline, utility, and industrial clients. So if you could advance the slide. What I want to talk about today is an application that we did for one of our major clients. They're a major refiner. It's a proprietary process, so I really can't reveal the names, and I can't talk much about the details of the process. But
can you tell us their names?
I'm sorry?
I'm kidding.
They have a proprietary production process that they've been rolling out at facilities across the country at a clip of about 20 systems a year. They came to us about 15 years ago and asked them to help automate this process and develop a system for controlling the process. So we've been working on this for quite some time. To do this, we assembled a dedicated team to work on this. And this is really what we do for all of our clients. If there's a substantial amount of work, we give them a dedicated team, and that creates efficiency and helps us to better serve the client. And we effectively work as an extension of their team. And in many cases, our folks understand the process and the systems even better than the client does themselves. So if you could advance the next slide, please. So a little bit about the services that we provided as part of this project. We designed a standardized PLC-based system to control the process. It's kind of a mid-size application, typically about 100 I/O points, multiple control loops, VFDs, and over 50 networked devices. We also developed the PLC and the HMI code. We designed the control panels and then had them fabricated for our client. Our engineering arm at some of these locations has also done the electrical, the mechanical, and the piping design. And then a big part of this project, obviously, and the part we're going to talk about today, is really kind of the testing and the commissioning, and that's a big part of what we do for the client. So please advance the slide. Oh, there we go. So as I mentioned, it's kind of a repetitive process. It's been going on for a number of years. And as you can expect, our client would like and really kind of comes to expect efficiencies and ways to reduce costs and do things better and quicker. There's some obvious things that come from just the repetitive nature of it. As you develop standards, you become more efficient in design. But we were looking for other ways to improve efficiency and reduce cost. So we started looking at the review, testing, and commissioning side of the project. Design reviews. Typically in the traditional approach, we'd have the client come into our office, sit across the table, we would look at drawings and review them, make changes, and then move on with the process. This was very easy to kind of convert to a virtual environment. Using readily available tools like Skype and Microsoft Teams, we were able to conduct these reviews remotely and save our client the travel time and expense. Another part, as I mentioned, we design control panels and then they get fabricated for the client. They would have to come out and witness that test at the shop. Over time, we began doing that for the client as really kind of the owner's engineer, making sure that the panel worked, the system functioned as required before it got shipped to the field. Another big part of the testing procedure is the software FAT and the process simulation. Again, we would typically do that in the office and run it against a full simulation environment that we had developed to be sure that the software's been validated and everything functions properly. Again, something that was pretty easy to convert to a virtual environment. We could do most of that testing remotely. But the biggest time commitment and where we think we realized the most savings is the on-site work. And that involved the point-to-point testing, calibration, commissioning, functional verification of the software. Typically, the way that would work is we would send a couple of our engineers out to the site, and they would work with the client team, with the operations and the technical staff. But it would take about 6 weeks. By converting to this virtual process, we still had a joint team, but our team was back in the office. The client team was kind of our eyes and ears on site. But with the efficiencies and some of the other things that we were able to do, we were able to cut that commissioning time from 6 weeks down to about 2 or 3. So advance the slide, please. So there's no magic to this, no special tools. We use commercially available web-based communication tools like Skype, Microsoft Teams. One of the tools that was pretty valuable was intrinsically safe cameras with microphones. So again, the client's staff would kind of be our eyes and ears, so they could go out and look at equipment, look at issues, and then we could help them resolve them and troubleshoot them remotely. Obviously, laptops with network access, hotspots were an important tool. And again, we had to have access to a client network, so we would have to work with the IT group to be sure that we could have the proper access. One of the things that we do when we're on site is tuning. That was a bit of a challenge. The software packages that we use usually require direct access to the PLC in the system. It extracts that data, comes up with tuning parameters, and we download it and tune the system. To do it remotely, we had to develop software to extract that information over the network, load it into the tuning software in our office, come up with the tuning parameters, and then download that to the system. Next. Some keys to success. The primary one is client commitment to the process. As I mentioned, it is a joint effort. And when our team would go out to the field, we would typically be there. We'd be doing a lot of things on our own. We would pull the client staff in when we needed help with something, but they would often get pulled off on other operational issues. So it's really important when we do this to be sure that the client team is available and committed, and we have a very well-defined schedule. Things that you would not even think about, such as lunch hours, breaks, become very important when you're doing this remotely. You got to be sure that people are in the right place at the right time, and you know where people are. So it does require more of a commitment. Documentation is always important, but it's especially important when we're doing this remotely. You can't take things for granted. So we had to be very careful about putting together the right checklists and procedures. Obviously, reliable network access is important, and cybersecurity is critical, another critical consideration. So, next. So some of the results and the benefits from this, as I mentioned, we were really able to reduce the duration of the commissioning period from 6 weeks down to 2 to 3. And that really is in large part due to the fact that we have to be more organized, have to be more committed, and those resources have to really kind of be on that project full time. Another benefit, though, is enhanced client engagement. We rely on working with the client and their team. They are more involved, but a byproduct of that is they learn the system better, and they're in a better position after we leave the site to maintain, operate, troubleshoot the system, and they can often do things that they would have otherwise had to rely on us for. This virtual approach also provides better response and access to a wider array of our internal resources. And typically we send 2 very well qualified people out to the site, and they do a great job, but it's just 2 people. By doing this commissioning remotely, they have access to all of our SMEs and experts. So they have a wider array of resources to tap and to utilize. We were able to cut down on travel. It takes at least a day to get to many of these sites. By cutting that out, our resources can work on other projects for the client, and we can more efficiently use them to implement solutions. Cost savings. On average, we were able to save our client 15 to 20% on the cost of these commissioning services. Another benefit to the decreased travel requirements is improved work-life balance and quality of life for our team. Everybody who works for us in the automation group knows that travel is just part of the job and you're on site. But 6 weeks is a long time. So by being able to let our employees spend more time working in the office, it improved their work-life balance, right, and really kind of it made them better employees, happier employees, and right, helped us to maintain them, or retain them rather.
That's great. Thank you, Mark. You actually came in right on time, so thank you for that. And sorry to let you go, but that was a great presentation. Thanks for joining us today.
Okay, and please feel free to contact me if you have any other questions.
Absolutely. And again, the contact information is here down in the description in the live stream, and hopefully people will be in touch with you. Thanks, Mark.
All right. Thanks, Chris. Have a good day.
You too. Okay, now we got to talk about more prizes to give away. So eliminate SCADA mistakes. Right, that's the winning phrase.
Right. So for your $100 online shopping voucher, it will be send an email to Natasha Lutz at trihedral.com. Eliminate SCADA mistakes. And eliminate SCADA mistakes in the subject line, correct?
Correct.
I'm just trying to make it more skill testing.
Exactly. And all uppercase with 2 spaces.
Right.
Excellent. So while you're doing that, let's move on to Mr. Alan Hudson. Now I'm going to make sure that I'm going to allow him to speak. Hi, Alan, you there?
Hey, I am here. Can you hear me?
I can hear you great. How's the weather where you are today?
Oh, the sun is out after the storm blew through. It's going to be a gorgeous 75 degrees Fahrenheit, that is. But the storm coming through put the rain down. The flowers are blooming. The green is coming out on the trees. It's going to be a gorgeous, gorgeous day and a gorgeous weekend.
I'm jealous. So where is it? We should probably tell people. I know where you are. Where are you?
Hey, I am in Birmingham, Alabama. Right there in the middle of Alabama, where the storms seem to come through on Sunday afternoons to bring tornadoes. But other than that, it's a perfect time to be in Alabama.
That's great. Now, of course, Alan is our head of U.S. sales, based out of Alabama, and today we are going to talk about. I guess we're inviting all sorts of people to come on and talk about their solutions, their strategies, their platforms. But today we also wanted to step back a little bit and talk about VTScada at a very high level, just to give people an idea. Some of you have never heard of VTScada before. You came here because you knew one of these vendors. So there's no better person to talk high level or low level or middle level than Alan Hudson. So. I'm just going to advance the slide here. So the first one is powerful. That's a $5 word. If I use that more than once in an article, I have to put a dollar in a jar. But why don't you tell us a little bit about powerful?
Yeah, absolutely. Well, one of the things since coming on board 4 years ago that I have really, really enjoyed is just the fact that when we show up and do presentations and I do lunch and learns or SCADA shootouts, I don't use PowerPoints. I will show the website for a few moments to talk about how everything is so transparent with us. But then from there on, I just show the software. And the software sells itself. Basically, there are about 7 or 8 very unique things that most audience members will take away from VTScada as being unique. There's probably about a dozen or 15, but individually there are about 7 or 8, and those things set people apart. And the cool thing is I use the exact same software and presentation and demo with a system that is running, say 3 tanks and 2 pump stations with just a few IO, up to the largest city or county that has multiple plants all put together. That it really doesn't matter the scale, that VTScada operates seamlessly across all those different platforms.
Yeah, I think because of the way our pricing works, people tend to look at us and say, "Oh, they're for smaller and mid-sized systems," but that's really never been the case.
That's correct. And it really, I tell you, it impresses a lot of folks that they can actually get our free version, our VTScada Lite version, for 50 points, and they can utilize it. They can start off a system, play with it for a while, and then say, "Wow, this is working so well. Let me move to the next version. What have I got to do to make that change?" I say nothing. You just install with a new license key. And from there on, you're off and running.
So easy to install and use. That's a big deal.
It is. In fact, I had a call just this past week. They were telling me that this customer says, I'm running version 9.1.1, and I want to use the new version 12.0. What have I got to do to make that happen? And they're used to having to, with the other guys, so to speak, the other software suppliers, that there's a multi-step connection to make things in the right order over and over and over, continue the upgrade, and then test it every single time. What I told them was, you know what, just simply install the new version of software and up it comes and runs. And it was that easy. So they actually went the other day to implement that, and they called me back and said, "Alan, you're right. It took me about 20 minutes." And I was totally, went from an older version to a newer version, and everything ran like it should have run.
Right.
So that forward compatible is a big deal. I see your slide there. I jumped the gun on that. And actually, I heard Glenn talk about that earlier today. Actually, the opening keynote talking about the forward compatibility. That was really a blessing for them to be able to look at that software and say the integrator that put this thing in some years back, I could reuse all of that, all of their time and their effort and all the changes throughout these last number of years, and it automatically upgraded. And they really thought that was fantastic.
Sorry, finger slipped. So we have about a minute.
No worries.
So trending everything, that's one of the strongest things we do is that pretty much anything you draw on the screen, you can trend with the built-in trend viewer. You can add as many trends as you like. An operator can create their own complex trend group and save that and reuse it. You don't have to bring in an integrator.
That's correct. And in fact, I was doing a lunch and learn last week, and within about the first 15 minutes of my WebEx presentation, the plant manager said, "I think we can stop now. You showed me this trending. They showed me the electronic notebooks on the trends. They said, as far as we're concerned, we're sold." I said, "Well, okay, but I'm not going to stop there." But you're right. We can trend anything with just a mouse click. It is so different than what anybody else is doing out there today. And with our built-in historian, Chris, and the ability of trending as many points as you'd like to, there is no limitation on that. It really is a game changer.
And just in a few seconds, we're going to actually mosey into this topic right now. But how do we eliminate mistakes?
Yeah, and I'll tell you what, if somebody could look at the year 2020 and do a version control back to December the 31st, I think they would do that immediately. But I will say that from our side, we can kind of do that right away. And it's all built in. It's all automatic. There's nothing to do as far as we are concerned. It's simply a matter of the ultimate undo button. As far as that's the way I kind of portray it sometimes, because there's nothing I cannot do to roll back from an application level change. And what's really cool about this, and I'll take just another 15 seconds, is I've showed this in my presentations. If I take and build an on-demand trend and I save that trend, let's just say Chris's trend until May the 1st, and now I go back into a rollback of my application, that trend I created is still there. It is absolutely blowing people away what can happen with our version control.
That's great. Well done. Like I said, you're the man to cover this material in that much time. And you and I are actually in a few minutes going to deep dive a little bit into version control and talk about how easy it is to use it, how you don't have to set it up. But in the meanwhile, just hang on there, Alan. We'll come right back to you in the next hour. Dave.
Right. So in the next hour, we've got new pump automation controller with Schweitzer. We've got operational resiliency with OpWorks, and network connectivity for geographically challenged systems with Quantum. So stay tuned for those. They're coming up pretty soon.
Great. Now, before we go on, I think we've got something to show you.
And we're back.
Great. Well, thanks for that. That video was created by Pete Diffley late into the night. So thanks for working so hard on that. And what that video really kind of shows is it just compares and contrasts how a typical SCADA system would approach version control and how VTScada does. Alan not only didn't see that video, he didn't know we were going to play one. So thanks for rolling with that. So at this point, I think we are going to head into our live demo, if I'm correct. Okay, so just bear with me here. We are gonna. You paid your 2 bits to see the high diving act. Pardon me. There we go. Bear with me, and look, it's our actual software. Ta-da! So what I thought we would do first, I'm going to be in the driver's seat and Alan's going to be, I guess, in the passenger seat. So if I miss anything, if I miss a turnoff, he'll be sure to tell me. So what I want to do now is, this is the latest version of our software. I just installed it yesterday. And what I'm going to do is in the application manager, I'm going to say add new application. What I'm going to do is I'm going to create a brand new application, and then we're going to look at version control. So we can see exactly how much configurations needed. So I'm going to say VTS for Virtual Trade Show, and I'm going to hit next and finish. So right now VTScada is building a brand new application from scratch. So everything that is in VTScada, and again, we sort of own every part of it, as Glenn was talking about, from the scripting language to the alarm dialer. All the core elements are actually built in. It's all built around our enterprise level historian. Right now the VTScada is churning away, and it just ding, delivered a brand new squeaky clean application. So this application's got a bunch of stuff built in. We've got our alarms page, our historical data viewer, which we were talking about trending earlier, Alan was talking about, the built-in reports, internet client monitor, operator notes, that sort of thing. But today, and built-in mapping, what I'd like to do is just go into one of our screens here. These are kind of inspirational screens that we create just to give people ideas. And you may have heard us talk about the Idea Studio, and this is the drag and drop environment that we use to drag and drop things onto our screens. So what I want to do is just something really simple. I'm going to go into our widgets, and a widget, of course, is a combination of images, shapes, and tag data. And I'm going to take what I think is a somewhat matching color. I'm just going to drop this on. This is not beautiful integration work, so forgive me. I'm just going to leave it there. Now, if I wanted to, you'll see it's cycling back and forth. It's just doing that to show us what it does. I can easily link it to a tag in our tag browser, but we haven't configured or imported any of those yet. But right now, I just want to show you that if I close this, it commits that change. There's our little dial on there. And that brings us to version control. So if I go up here in the top right-hand corner and I hit the application configuration window, I'm going to go down here and open the version log. So you saw me create this brand new application. One of those components that were built in is this version log. It's all ready to go. So you'll notice that everything we've done, this was the change we just made right here. Up here, we've got all of the computers that have ever touched this. If you know VTScada, you know that we do redundancy seamlessly. So if we had, say, 4 or 5 different PCs that made up this distributed system over a LAN or WAN, you would see them all listed here. And down below, you would see all of the changes made by every user on every server in the entire system. And you'd be able to go in and inspect them. And today we're going to decide that this change I made was a bad change. And I have to agree, it was not a good idea on my part. So I'm going to go to the version just before it, and I'm going to say switch to this version. And what it's going to do now, it's going to show me this is the code. So we were talking to Glenn earlier about VTScada script, our native scripting language, and this is it. This is a very simple example, but this yellow text is the script that represents the dial that I dragged onto the screen. And this is the change that I'm going to roll back. So if I open things up a little bit, you'll see on the side over here, you'll get a check mark that shows basically you can burrow down and see every one of those changes, whether it's a configuration change, a settings change, or a change to a page. So I'm going to go ahead and apply that. And I have to put in some kind of a note so that we can see that. We'll see that note a little bit later. And I'm going to hit OK. And you'll see that that's gone. And you'll see that that change isn't gone, though. We've just rolled it back. It's still there. We haven't lost anything. It's all right there. Alan, we've got about a minute left. I've used up all our time. Do you have anything you want to add to that?
Actually, not really. I will say this: it's really kind of cool the way we show the colors. Yours showed yellow means we're going to remove something. Green means we added something. We also have a red and an orange if we had some sort of a conflict. You know, you mentioned the multiple servers. We do support multi-developer environments. It also means that even in our virtual world today, as we heard in the previous presentation, you can have different people making various changes in different locations, and when those are applied, we see that immediately populate the entire version control. So it really makes no difference on where you're sitting, what you're doing. Every one of those application changes are captured, and now you have the ability of undoing or merging any of those changes so that you have, again, the ultimate undo button. It's a phenomenal feature, which I think is one of the premier pieces that sets us apart from the other SCADA offers.
That's great. Thanks, Alan. I appreciate that. That's a really good point. And now we've covered that at breakneck speed. I'm going to close VTScada. Thanks for joining us today, Alan. I think you're going to join us a little later, aren't you?
I will. Yes, sir.
Excellent. Look forward to it. So let's move on to Mr. Tim Pilcher. Hi, Tim. I have to unmute Tim. Hi, Tim. You there?
Yes, sir. Good morning, Chris.
Good morning. Thanks for joining us today. So where are you calling from?
Well, I have to say I'm a little bit jealous of Alan. He's up in sunny. I'm down in the southeast part of the state where we're getting pummeled by tornadic weather as it screams through the south part of the state in Florida, and similar to what we experienced on Sunday and the last Sunday before that. So it's I think we're through the first part of it now. But if you start to hear a lot of rumbling in the background, that's the
yeah, just go if you need to go, by all means. I'm sorry to hear that. So thanks for joining us. That's great that you still took that time. So today you're going to talk to us about your pump automation controller. I'll let you jump right in there, and I will drive the slides. Just say next, you're back.
Great. So I'm very excited to be able to present here with VTScada, and thankful that they're giving us an opportunity to talk a little bit about our company as well as one of the many products that we make. So if you've never heard of SEL before, we're an employee-owned company. We design and manufacture all of our products in the U.S., and we've been involved with critical infrastructure for the last 35 years. 99% of our business is in the electric utility industry, which we support with free technical support. So even through these times where the future's a little uncertain, we enjoy being able to serve and make sure that our critical infrastructure stays running. And we do that by focusing on solving problems and staying close to customers. Next slide. So I'm going to talk to you about a product that we made with our customers by request to solve a problem. Many of our customers are municipalities that have electric as well as water, wastewater, and other services. And the way we solve problems is we follow this simple statement. We understand, create, and simplify. And so we get close to customers to understand what we're trying to solve, and then we work with them to create a suitable solution and then continue to simplify that solution over time with the customer. Next slide. So I'm really happy about introducing this product. It has been released since 2016, but it is the first product that SEL has released that is specifically for the water wastewater industry. Obviously, we have other products that fit for power distribution, protection, and things like that, but this one is just for the water wastewater industry. Next slide. So what's different about this product and what we bring to the table is that this is a hardened pump controller, and it's designed not only to exist in these remote applications where the environment is less than ideal, if we could say, but it's also built for simplicity as well as reliability. Next slide. So the applications where this fits is all the way up to a triplex station with logic out of the box. It can facilitate a quad station. But it's for those remote and harsh locations where you need a simple to use, a simple to integrate pump controller that's going to last in those harsh environments. Next slide. So one of the problems that we learned about with our customers was reliability in these really, really nasty locations where there's a lot of challenges, environmental challenges, and we build our products to handle that. So we knew we could add value there. The other place is flexibility. You'll notice that our product uses non-proprietary SCADA-ready protocols like DNP3 and Modbus. And then our product also has an HMI that provides a lot of field visibility for quick troubleshooting. And then our data is time-stamped on board with the product, and also delivering that time-stamped data back to SCADA allows for accurate analysis of how your system is operating. Next slide. So you might ask about how do we make a reliable product, and what does that mean? So all of our products are hardened because we have a no questions asked 10-year warranty. It doesn't matter if it gets hit by lightning, you drop it off the bus. I had a phone call yesterday, somebody filled a cabinet up with water, okay? No questions asked, send it back. We're gonna repair or replace it for free. We designed these products to handle these environments for up to 20 years, and after serving our customers for 30 years, we don't charge for repairs, regardless of the product age, regardless of even if we don't make that product anymore. Next slide. So what do the results look like from designing these robust products? So this 2411P hardware has been around since 2005. We put a new firmware package that allows it to be a pump controller. But the results of this mission-driven design translates to fewer operational dollars spent on troubleshooting, labor hours for diagnosing problems, repairing and replacing and recommissioning stations, and any other application where our products are involved. In fact, the calculated mean time between failure on this product is 900 years, which means that if you had 900 of these products in service, you could expect to see one hardware failure per year on average. And in that situation, you would send it back to us and we would repair or replace it for free. Next slide. So we designed these products to handle extreme vibration, electrical surges, fast transients, extreme temperature swings, because we are in the business of making sure that critical infrastructure stays up and running, and you know what's happening out there in the field because our products are out there controlling and bringing back data and operating as you expect them to operate. Next slide. An additional layer of protection that we've added for our products is you can proactively add conformal coating. Our pump controller comes with conformal coating by default, and this conformal coating is a compound that covers all of the electronics that are coverable on the boards inside the device. You can open the device up and look at the boards and see how that's coated. And then this helps protect it from corrosive gases that you'll find in lift stations and water wells and booster pump stations, high humidity, salt spray for those utilities that are on the coast that experience that. And so conformal coating is just a way that we continue to protect that investment for you with our product. Next slide. Aside from making a hardened device that we want you to be able to enjoy for 25 years, we also want to keep it really simple. And that means not locking you into a specific IO block. So we have flexible IO options. You can add IO cards in the future, or you can create your own custom IO when you're ordering the product. And so as those applications that are, those stations are out there for 20, 50 plus years, being able to continually add additional features and cards in the field as that application grows or changes is something that we want to be proactive about providing you with that capability. And also it means, not locking you into a specific protocol of communication back to SCADA systems. As SCADA systems change and evolve with updated firmware, we can facilitate that, and we want to be proactive about that. Another thing that's really neat about the 2411P and all of our products is we have what's called an SER report. and data buffering and logging, which allows you to be able to get timestamp changes in the device recorded and delivered back to SCADA over protocols like DNP3. It keeps the customers and the guys in the field from having to guess about what happened. They can make decisions and get to root cause a lot faster, which saves a lot of money. Next slide. So as we get closer and closer to customers using this product, this year in December of last year, we released a new firmware that allows you to be able to answer about 4 questions from the front screen that sets up how you do level control for your station. So it doesn't matter if you have have floats only, analog transducer only, or a combination of both. You can customize that by going through this short interview process. And it allows it to build that custom logic for your custom station in a simple way. And that includes any of the fault detection, plain text alarms, and failover modes that are part of that configuration. Next slide. So when you look at how to save money in these applications and with a reliable device in the field, the 2411P is a pretty nice economical value at $2,100 for just a station with floats, a triplex station with floats. You can add analog cards to that configuration as well as some other cards to complement that installation, but we don't charge for configuration software. We don't charge for protocols like Modbus and DNP3. We don't charge for tech support. I'm on technical support, and you get me on the phone or any one of our 100 application engineers throughout the country to support you day or night. And of course, you got that 10-year warranty, no questions asked, standing behind you if anything happens to the device. Next slide. And what does it look like?
Just a few seconds left. Yeah.
Oh, that's good. So this is my last slide. I want to hang out right here just for a second. So this is how we support critical infrastructure. We provide hardened devices in the field, and if you have an issue, we're going to be there behind you to help you get it back up and running as quickly as possible.
That's great. Thank you, sir. Thanks, Tim. I appreciate that was a really great presentation. It's nice to see that commitment to support. It puts a lot of people's minds at ease when they're spending a lot of money on hardware.
Hey, I'm glad to do it. Thanks for the invite. I appreciate it.
Our pleasure. Thanks for joining us.
Right.
And of course, his contact information is available on that slide, which I just went by, and also in the comments and in the description for the live stream. Now it's time to win again. It's time for another contest of skill. So the phrase of today, or the phrase of the moment, where's my mouse? Application version control. So please send Natasha Lutz at this email address with this phrase in the subject line, spelled exactly like that. We are using machine learning to filter out these answers, so you have to get it exactly right. That's me, by the way, jumping up in the air. Okay. So while we're doing that, now we're back to Alan Hudson. Hi, Alan. You still there?
Oh, I'm still here, and I'm typing in application version control as fast as I can type it. Woohoo!
Well done, sir. And thank you for noticing our similar haircut. Yours is what I base mine on, so I'm waiting for you to get glasses.
There you go.
So we're going to talk a little bit about the sales team.
Fantastic. And I know we have just a couple of moments here, and I will say one of the beauties of the way VTScada goes to market is we really believe in getting our people out in front of customers, with other partners as well. I mean, we heard Tim talk about the SEL controller. Tim and I have spent a lot of time down in the panhandle of Florida, throughout Alabama, connecting in VTScada and the pump controller. And so one of the things we'll do with our software is give a 90-day trial, if you will, so a customer can actually run this thing live as a demo in their system to test it out. Well, you can't do that if you're trying to maintain everything else over a website. You can see on the slide there these various dots around the country. Let me just do a couple quick things. So in Nova Scotia, that's way east of here, you got Pat Cook. And so Pat comes into the Carolinas, into Virginia, that whole Maryland, Delaware, whole New Jersey, even has come up to the whole East Coast for a lot of years. He's a staple in the industry and also has a haircut like ours, and it's just fantastic. But we have Brian Sinkler down in Florida. Brian came on board about a dozen years or so ago. What's cool about Brian is he actually spent most of his career in a city of Ocala, Florida, doing just what we're talking about today. I mean, he started in the trenches, but worked his way up into the SCADA side of things. And so today, one of the values he adds to customers in Florida is that he's been there and done that, and he understands that component of it. And so it makes it so much more effective as we go and build that out. So the next one is Blair Solis. Blair's been around VTScada for about 15 or more years. I knew Blair back in the day before I joined VTScada. And Blair moved to Texas right at 4 years ago. And his expertise, knowledge of the product, as well as oil and gas, water, wastewater, and even power systems, has really driven all of Texas to grow in exponential fashion. And so some of the things he's done recently are things like working with the city of Houston, Texas, as that SCADA shootout selected VTScada to move forward in their system. And so that's just continuing on. You see the picture up there for Dan. Dan's in Chicago. Dan comes out of the IT world and in components, in virtual industrial electronic pieces. And so Dan is adding a whole new realm to what we're doing today because of his background in that. But he's been with us now about 2 years. We got Mike Stark. Now, Mike's been around for a lot of years as well as an integrator in the Ohio, Kentucky, Tennessee areas. And so he comes on board almost a year ago. And what he's been able to do is reach out to a lot of municipalities that have done SCADA software upgrades in the past and take them to what VTScada has to offer. It's been very, very effective by having him on board. And Tim's the same way. Tim is up in Massachusetts. I can't spell it, but I can say it. And Tim is taking care of the Northeast for us. So Tim comes also out of that world of knowing a lot of other SCADA softwares as well as other auxiliary components that make a SCADA system complete. So very effective. And of course, you see my pretty picture there. I am in Birmingham, Alabama, but I also take care of the West Coast. I'm really looking for somebody out west. Our business is growing very, very fast out there. So to all the listeners, I don't want to take you away from where you're working, but if you know somebody who would be a great sales engineer for us, we would love to have somebody with feet on the street who lives there on the West Coast somewhere. So again, reach out to me. But until then, I take care of that. And then finally, we go up into Western Canada, up in Calgary, and that office continues to grow because of the great success we've had with not only water, wastewater, but really the oil and gas very, very effectively. So we have Luke up there who is really taking that office and taking it to a whole nother level as well with training classes and those kind of things that are local, on-site, and centralized there in Western Canada. So that's our U.S. sales team. We have, of course, you, Chris, and Dave, and others that will come in and out. We also have people like Glenn and Barry that will come in. We have other engineering people that come in. All those kind of things are available to us, and we bring that up all the time. So take us, use us. Our website has a great place for contacting us, so don't hesitate to go there, reach out to us, and we'll come take care of you.
Thanks, Alan. That was great.
Cool. Thanks, Alan.
Alrighty. Thanks a bunch, and we'll move on.
All right, guys.
Talk to you soon.
So, Chris.
So next we're going to move on. Oh, go ahead.
I was just going to say, up next, Colton James with OpWorks, is it? I'll let you pull Colton in there whenever you're ready.
Okay. Hi, Colt. Oh, that was a subtle nod to me. Well done. Hi, Colt. How are you?
Hey, doing well.
Sorry, Colton. How's the weather where you are?
Right now in Minnesota, it's, I think, like 65 degrees, which is a heat wave up here. So we're pretty excited.
That's great. So today you are going to talk to us. Sorry, I'm advancing slides here. So we're going to talk about operational data reporting and resiliency, which is very important these days for a lot of different reasons. Obviously, with what's keeping us indoors these days, but also with larger issues in terms of aging populations and things like that.
Right. It's a bit of a buzzword, but what we try to do is make it simple for everybody to understand and be able to implement.
So why don't you tell us a little bit more about how you do that?
Yeah, so real quick, OpWorks is a software that is web-based and basically brings together all facets of the operations to one place. It's cloud stored, so you don't have to rely on servers, but we do a little bit of asset management, data management, and maintenance to make things easier. And one thing we've been experiencing in the water and wastewater field, and probably many more, is this idea of aging workforce. And we've kind of talked about it as the silver tsunami, which is a funny term, but employees with 30 or 40 years experience are starting to walk out the door, and we want that to happen, right? You've done a great job running our facilities, and we're proud of the work you've completed. But with that, you have people leaving who have a wealth of experience and institutional knowledge. And what we're really trying to accomplish is to take that knowledge and bring it into a platform where it can be used and reused and updated as plants adjust. So that's part of what we're trying to address with OpWorks. Another thing, for anybody who's run water, wastewater plants and probably factories and industrial settings, we all have quirks. And there's always a quirk that isn't written down. And there's a pipe that nobody really knows about. It's not on any plans that is really critical to the plant's success. Now, that sounds simple. It sounds like, hey, we should just put that on a plan. But for almost every plan I've worked on, that's usually never the case. And it's sometimes hard to get that data transferred. Also, trending. A lot of these operators have seen it all. So they've understood when these inputs come into my plant, these are the expected outcomes. But without having people there for 20 or 30 years, the folks come behind after that retirement have to learn the hard way. And what we want to do is minimize the hard way. And finally, relationships. When we talk about relationships, it's, there's internal relationships, but there's also external. Knowing what pump manufacturer to call, or who fixes the blowers, or who comes in and is able to help out. If our operators all get sick at the same time, what town can we call to get support? And these are really items that sort of touch operational resiliency that are so key that you don't want to be looking for when tragic things happen. Which leads me to the next point. Things change, and things change fast. And sometimes you have family situations or really items that people weren't prepared for. And I've had one operator who called on a Tuesday and said, Wednesday's my last day, I'm moving to Maui. And just kind of was like, all right, man, do it. Good luck. So we just want OpWorks to help build it. And the way we do that is through implementing SOPs, photos, videos, and notes. But we do that through document management that's actually associated with the asset, the pump, the blower, the valve. So you make it easy to get to. We don't want the binders. The binders are dusty. They don't get used. People never know if they're up to date. And that's one of the struggles that we've seen as people manage transition. Another item we call shift notes, and we'll talk about it a little more, but shift notes are really operational logs. And this is where you get passive transfer of knowledge. So passively, people write down, hey, today I did, whatever to this pump. And over time, you're able to pull that data back and look for trends over time. Like every June, we have a certain issue. Or maybe there's, in March, we struggle with snow melt and it causes this pump to act up, which again brings us to operational resiliency. So real quick, operational resiliency is a huge subject, and we just try to carve out a little bit that we feel we can control a little bit easier. So maintenance, a good, strong operational team should basically plan as much maintenance as possible prior to explosions. Right? You don't want to be reactive, you want to be preventative. So scheduling maintenance. Also, we're going to touch on it in a little bit, but this 3D facility viewer is just another way that we want to make the process of transferring knowledge and really understanding what you're working on without maybe having to go into places that maybe aren't safe. Real quick, if you jump back, sorry, the slide about, so automated compliance, I've heard some other people do automated compliance reporting. We do too, and it's something if you're not doing today, you just should be. But one tool is a QR code. So everybody should know about QR codes. They basically hyperlink to whatever you want it to be. We can put it on pumps and assets, but what we like to do is actually change it a little bit. Where if you have a well where there's very few components in there, just like chemical feeds, you can walk in, scan it with your iPad, and it takes you exactly to the screen where you're going to enter information. And the way we like to leverage this is with like summer help or new operators who haven't been there and maybe you're just learning. This is a simple way to just make it as simple as possible so you minimize mistakes and that data can actually be reviewed and ensure that it's quality. So these are just a couple tools where if something happened that was unfortunate or an operator had to leave, you could have somebody come in behind because you've basically templated and you've checklisted your entire operation. So next slide. OpWorks does a lot of stuff and we're proud of all that it does. But some of the items we've talked about, document management, of course, but SCADA we haven't discussed. We integrate with SCADA, and that is just another way of pulling in real-time data or aggregated or replicating historian data and pulling it into the cloud to make sure that you can leverage that data for, let's say, maintenance. So if you have hour run times on a pump, you can schedule that maintenance per, I don't know, 500 hours. You can kick out a preventative order. Another way, like we talk about shift notes, that's passively pulling in institutional knowledge into a system. And then one that I don't talk about a whole lot is charting. We kind of purposefully don't have a complicated charting system because what we found is operators just want to see the trend. They just want to see, you know, on Tuesday I had this lab result and these were the conditions in my plant, and just try to basically find a simple correlation because they don't really care about the fancy data analytics that can be done. So again, making it simple for operators is key. And then the next slide is we kind of keep jumping.
You have about 2 minutes.
Great. So the thing we've talked about, the 3D facility viewer, when I was in utility management, I used to struggle because there were young operators who sometimes got confused in large buildings. And that sounds silly, but there may be 10 blowers in a building and they would want to know which one's which. And instead of saying, well, it's blower 8214, come on. You can just show them through this 3D interface. It's this blower. It's the third one from the left. It's purple, and it has this number on the front. And you can either do that by leveraging a Revit model, or you can do that by, there's some really fancy cameras that do basically 3D photospheres. And we've stitched those together so you can hyperlink and jump through a facility to make sure you know what maintenance needs to be done. And you just ensure that there aren't mistakes where you change the air filter on the wrong blower. So as we kind of slide in summary, OpWorks is a tool to make operations easier. And the way that we've done this is we've built in systems that can draw in information so that you're not always relying on the guy who's been there, or the gal for 30 years or 40 years telling you how to do it. And this is one of those keys where a little bit of planning, a little bit of practicing, trying new ways of training people, it's really an important asset to any facility. And that's how we as OpWorks push to make transitions easier and making it as simple as possible.
That's great. So tell us, you connect to SCADA systems, of course, and of course we are a SCADA system. Can you tell us a little bit about how OpWorks interacts with VTScada, for example?
Yeah, so VTScada was actually our first SCADA implementation in Rapid City, South Dakota. And we got lucky. Y'all were really great to work with, and also your replication tool made it very easy to pull that data from Rapid City into our cloud. So again, there are other companies that are less easy to work with. It just depends, right? But
right.
That's something we're really pleased about.
Oh, I'm glad to hear that. So for someone who has none of this, who is sort of looking at this presentation and saying, yeah, there's a lot of gray hair around here, we ought to be doing something about it. What's the first step before they even call you?
I think looking around and finding out what documents they have or how people are actually doing maintenance and
Right.
getting that historical knowledge documented. Of course, OpWorks helps with that, but we want people to work in collaboration with us.
Of course. And once they've got those ducks in a row, what's the next step?
Yeah, either come to our website, so opworks.us, and schedule a demo, or connect with me on LinkedIn, and we'll set up a time where we can show you what we can do and hopefully improve your operational resiliency pretty fast.
That's great. So as you can see, the website's the bottom left-hand corner of the screen. You'll also find it down in the description on the live stream, and you'll be able to go. Now, do you guys have like a live chat feature on your website?
I don't think so yet, but I've heard we are talking about that.
Oh, great. Excellent. Well, thank you, Colton, for your time today. That was a great presentation.
Hey, appreciate it.
And next we are going to go to a contest. Or are we going to a contest now? I think we're going to talk to Mark Reske. I just unmuted Mark. Are you there?
Yeah. Hey, Chris. How are you?
I'm great. Thanks for joining us today.
Yeah, thank you.
Now, where are you located?
Beautiful Arizona. Unlike your previous guest, Colton, we're going to hit about 100 this week. 100 F.
Holy moly.
Yep.
I'm a little bit jealous, I guess. So now tell us, how are you with the new business environment and everybody working from home? How has that affected your business?
Oddly enough, it hasn't impacted us too much. The only challenge that our staff and engineers have faced is it's just been a little bit more challenging to get people to pick up the phone and respond to emails. Right. But for the most part, things are moving along.
That's great. I'm glad to hear it. So I guess the next question I have for you, going to your slideshow, tell us, this is my first question when I saw this, what is a geographically challenged system?
Yeah, so, over the years, I've learned that most manufacturers of industrial control systems have been really focused on the plant floor. That's great. It always has been their niche, but there's a lot of people that aren't always at the plant floor. They have geographically separated locations. And if you can go to the next slide, Chris, it would help out to depict what I'm talking about. Yeah, so for example, water, wastewater, mining, gas, those are all geographically challenged industrial control systems. They're not all contained within a plant. They can be spread out over miles, and typically these geographical pockets of control systems usually feed a primary plant or process. And typically what depicts a remote system is it has a wireless communication system involved. And if you don't design that wireless system properly, it can lead to some serious headaches and frustration and whatnot. And if you can go to the next slide. So some of these, the things that people experience over the years, I've seen geographically systems be installed, is if they're not designed properly, it can lead to latency problems, continuous sending of commands. I know I've seen operators just constantly click the mouse, auto, or run, or stop, which is even worse, until the command goes through. And that's not good practice. That's not how it's supposed to work. The other thing you see is constant communication alarms coming across the alarm banner. This site dropped out. This site dropped out. Eventually, operators just get fatigued and they ignore those, and that's really bad. The next thing that could happen is you're going to have a lot more personnel intervention that happens, or equipment's just going to be put in manual control. And to be honest, you bought a control system to have less people intervening with the equipment, and your return on investment is going down. So it's really imperative that geographically separated systems are designed properly. So some of the stuff that you can really look into quickly is, the big thing I always stress is network segmentation. And there's a lot of benefits on that, but the big benefit is the broadcast traffic goes down, which I'll explain shortly. The other key thing to keep in mind is understand the protocol you're going to be using over a wireless network. Some of them are a little bit more intensive than others. Ethernet IP, mostly used in Allen Bradley PLCs. It's great. I love it. It's a little bit more intensive than Modbus, so you got to be careful there. So that kind of leads me to my next point. Pack your data properly, use smaller tag names, and optimize UDTs. And I'll kind of show that later on too. Leverage communication drivers that allow you a little bit more flexibility in polling. And I know VTScada has that. You guys have always been very good with that. There's also some other manufacturers out there, mostly communication driver companies that also do that. So if you're not a VTScada user, don't worry. There's other people out there that can assist you. You also got to understand your wireless limitations. 900 megahertz is not the same as 2.4. And just because a radio has an Ethernet port doesn't mean you're going to get 100 megabits through it. And I'll kind of show that soon too. The other thing to keep in mind is staging your messaging. So that kind of leads into the last point, which is a data concentrator PLC, where you can say, hey, pull this site, site 1 every 5 seconds, then go to the next site, pull that one 5 seconds, go to the next site and pull that one 5 seconds. So previously I talked about, just because a radio has an Ethernet port in it doesn't mean you're going to get 100 megabits per second. So what we're showing here in this graphic is we got 2 PLCs, 2 radios that are 900 megahertz. And I've kind of shown that the Ethernet cable gets 100 megabits per second, not bytes. And then the radios, at best, I have to reinforce that, gets 1 megabits per second. Significantly slower, as you can see. So if you could press the key one more time, this is what the equivalency is, and this is what I try to explain to people when they're using wireless systems. It's like taking a fire hose, connecting it to a garden hose, and then connecting it to a fire hose again. And I don't think that's going to work very well, and I'm pretty sure the garden hose is going to be the thing that fails. And oddly enough, in today's world, in the systems I see, it's usually the wireless communication systems that challenge these geographically separated systems. So there's some, really quick, just go back to one thing, Chris, if you don't mind. Go back one slide. One thing you want to keep in mind when you're troubleshooting radios is you want to look at this received signal strength and the signal to noise ratio. It's imperative that you look at both. Me personally, and based on the studies I've gone through, I'd rather see an improvement on the signal to noise than the RSSI. If we can bring down the signal to noise ratio or increase it so that the noise would go down the floor, that means there's less chatter on the wireless medium out there. So go ahead and go to the next slide, Chris. So the one thing that I see that plagues most geographically challenged systems is that most people design the system to be a flat network. And what I mean by flat network, it's shown in orange, where you have the same IP address scheme used across all the PLCs, all the SCADA nodes, all the radios, and the orange dots, the circles indicate broadcast traffic that just goes everywhere across the network. The triangles indicate the data we're trying to pull across from a PLC to our SCADA node in the bottom. And as you can see, all the orange traffic is going from every PLC to every OIT and SCADA computer. But one thing that you can really do to improve your wireless communications is if you segment the networks. And that's shown on the far right in the multiple colors. As you can see, I'm using different IP schemes at all the various nodes. And you can see that the circles are not traversing over the wireless network. And that's great because we're containing all that broadcast traffic at the site and not consuming precious bandwidth and throughput. And this also holds true when you're using cellular. You don't want to just consume data for nonsense. You only want to transmit what's relevant to your application. So what kind of is the difference between these two systems is that the individual sites have layer 3 components or routers. And that's, for the most part, the core part that's going to help you do this successfully and implement it. But there's a little bit more you can do, but that's a high-level overview of how you could segment your network better and see overall performance increase. So if you can go to the next slide.
2 minutes.
Okay, wonderful. The last item I wanted to just kind of briefly talk about, Chris, is I mentioned Allen Bradley PLCs, and there's a lot out here in Arizona on the West Coast and water, wastewater. And they're great. I love them. And they have, UDTs you can make. And what I'm showing here is I got a UDT that says STR1, STR2. And I'll just tell you guys that the UDTs are identical with the amount of names and commands in there. The only difference is you can see that the data types are organized with all the bools in one area, all the reals in one area, and all the integers in one area. And I see this a lot, and it kind of drives me insane. My name looks like it's covering up, there we go, I moved it, is covering up the data type size. And as you can see, the data type size is different on these two, but they have the exact same information contained in them. So you got to understand how the processors compile this information. And as you can see, there's 12 bytes of data difference here. And that 12 bytes can add up over time, especially if you're going over cellular. And you got to transmit those extra 12 bytes, but it's passing the exact same information across. So you got to learn how your processors work and structure them accordingly, all your tags. So those were kind of just some things I wanted to talk about briefly that I see that you could really improve on right away, Chris, out in the field. There's a lot of other stuff out there too, and I can always talk about that at a later time.
That's great. So that's a great presentation. So again, I ask this question a lot, but when people are ready to look at this kind of technology, to look at this kind of solution, what's the first step?
The first step, I would talk to someone that specializes in the industry, and look for a company that possibly has a Cisco certified network engineer on their team, or someone that's actually taken networking classes and are familiar with that. So you really need to find someone that specializes in the controls world, in the networking and designing area. That's how I would approach it.
Gotcha. And roughly what's from the point when they approach you to the point where you've completed your work with them, how long does that usually take?
That's a challenging question because, I've got clients that are, 10 sites, and then I've got clients that are several hundred. So it really depends, and it depends on their infrastructure. We've made improvements on systems in a week, once we procured it and done a test internally. And then there's some systems that just take a long time because we got to phase them out. It could take a couple months because we just can't impact how they run.
Well, I guess it's good that there's no one size fits all answer.
No, there's not, unfortunately, and I wish there was.
Well, thank you very much for
everyone would do it.
Exactly. That's right. And we pay them half as much. So thanks for joining us today, Mark. And thanks for jumping into our crazy live stream. Have a great day.
Yeah, I enjoyed it. Thank you.
Okay. Thank you.
Yeah, bye-bye.
And now it's time to win again. Putting on my game show voice, which is getting a little hoarse. So you know the drill, or if you're tuning in late, please type in Natasha Lutz, natasha.lutz@trihedral.com, and in the description field, write "We Trend Everything," all uppercase, 2 spaces.
And that's in the subject line there.
Sorry, in the subject line. I'm getting punchy. Oh, things are going to get crazy from here on in.
Right.
So yes, please do that immediately.
While people are doing that, Chris, you and I are going to chat about support a little bit.
Oh, yes, that's right.
So
I'm also not looking at my camera at all. I'm just kind of staring off into the distance.
I know, it's really tricky. Both Chris and I have a lot of other things going on in the background, and so we try to look one way, but we spend a lot of time actually trying to fiddle with. It's one of the downsides of touchscreens, I think, is you can't hold your finger on a button.
Right.
So that last presentation was really great, Chris. I think I will note that we do have we've had deadbanding of the historian data for a long time, but we are going to be deadbanding driver data, which will make a huge difference on how much VTScada traffic gets propagated out, not necessarily from the remote site, but I think that's between other VTScada services where you have a VTScada installation somewhere remote connected to another one that may be wireless. So anyway, it's just a point that is up and coming. So when we look at support in VTScada, I know this has always been something that was a real focus of the VTScada team, but it's also something that actually drove partially why VTScada Lite is free software. Was this mentality that the level of the support can't change for anything that we charge for. So they kind of I know Barry and Glenn kind of going back and forth for a little while talking about that and wondering how we meet our level of support, but also put out a software that's fit for the small tag count market. And at the end of the day, they basically said, well, we'll just give it away because we're not going to be able to have full call-in support like we do on the paid product. So we decided to set up an online forum. So it's forum.trihedral.com for anybody who's using VTScada Lite. You can post your questions there. And you've got developers, you've got the tech support people, and you've got people like Chris and myself who, and as well actually quite a large growing community now of people who will put those in. So, Chris, did you want to talk a little bit about support itself and just kind of, I guess, try to throw a few of Glenn's words at it?
Sure. So I think that is one of the things that really kind of sets us apart. I think that's one of the ways we really made our beachhead in the East United States many years ago. The way that SCADA customers, unlike manufacturing customers, they talk to each other. So Coke and Pepsi don't swap great stories about support or great SCADA solutions, but water utilities typically do. So when we moved into, say, the Florida area, the Carolinas, we built our beachhead not only around good software, of course, but around the ability to provide an elevated level of support. So that's something that's for the people. I write a lot of articles about successful installations, and whenever I'm interviewing people, they always stop me and say, now your software's fine. I love your software, but the thing that really keeps us paying for support every year is the quality that we get from that. And like Dave said, well, basically, if you buy VTScada, you get 3 months of our basic support, and that is phone and email support with our support staff. And we have a large number of support staff, so we've always got the phones covered. We guarantee 1 day response time, but typically you call and talk to a human.
Right.
You would almost always call and talk to a human.
And Chris and I go to the development meetings reasonably frequently, and in those you get the support staff talking to the developers. And it's funny, they don't talk about customers by number or anything else. They're talking to Glenn and other people about who's calling in and what they're asking questions about. They're talking to them by the name of the person, and everybody, even the developers, other people, tend to know the names of the people inside of the product. So none of our customers are sort of a customer number. They're not asking for support up front or anything like that, or what your number is. They're basically just looking to sort you out and then looking to deal with it.
And we got about 10 seconds. So just the moral of the story is that our support is an important part of our product development. That kind of, it's the completion of the feedback loop. The contact we have with the customers allows us to make sure that the software, and we just released a new version of the latest version, where every couple of weeks we're putting out new versions with fixes, new features, and tech support is a vital part of that loop.
And those people with tech support can upgrade at any time.
And you can go to our website and find out more about that. But in the next hour, we're coming up right now is BlackRock Automation, which I'm looking forward to. I just wrote an article about this application, and then increasing lift station efficiency with Made Labs. That's a great presentation. And zero two-waste filter control system with Filter Magic, and finally ICS cybersecurity fundamentals with Jacobs. And that should bring us almost to the end. And now that brings us Brendan Hart, who I've just unmuted. Hi, Brendan, are you there? You perhaps not answering because I called him Brendan, and he's Brandon. Hi, Brandon. I'll try that one more time. Everybody talk amongst yourselves. Oh, I know why. There's more than one person in the queue. Now you should be able to hear us. Brandon? Brandon, how we doing?
Doing good. Chris?
There we are.
All right.
That was my human error. I apologize. A few too many things happening at once. How are you today?
I'm doing great. Yourself?
I'm great. Now that I can hear you, I'm doing fine. Yeah. So where are you?
I'm in Calgary, Alberta.
Right. So you've been in contact with our Calgary office, I assume?
Yeah, I have dealt with Lou there a fair bit.
I'll bet. So how's the weather?
It's great today. We finally have spring.
Oh, I'm glad to hear it, especially for you guys. So we're going to talk about your hosted solution that you came up with, and again, I was fortunate enough to write an article about this nice application. Can you just open up by talking about? I know some people know obviously what a hosted SCADA system or a cloud-based SCADA system is, but would you talk a little bit about how that is different from a standard SCADA scenario?
Yeah. So the concept of cloud hosting is the term for on-demand computing. It's generally over the internet, and the result is, from an end user's perspective, there's no hardware or maintenance required. It's all just exists online. So for us in our SCADA application, then we have VTScada running on a pair of redundant cloud-hosted servers that can connect to anything that can connect to the world. So
that's great. And so there's a lot of advantages to being able to do that. Actually, could you lean into the mic just a little bit?
Yeah, sure. Sorry.
So I guess I skipped over allowing you to talk a little bit about BlackRock. Tell us about your company.
Yeah, BlackRock Automation was started in 2010, and we provide integration, development, service and maintenance, primarily for oil and gas, but more and more for other sectors as well. We're loosely based in Calgary. We don't have an office. We mostly work from home or our trucks. Right. And but we have 25 employees spread across Western Canada, as well as a recently opened office in Houston. We work on all sorts of projects of all shapes and sizes on a variety of platforms, and we've been VTScada integrators since 2014.
That's great. So what brought you to, what was the problem you're trying to solve that resulted in you creating your own cloud-based SCADA?
Yeah, we were running into companies of all sorts and sizes that were looking for data gathering, remote access, and the other advantages of a SCADA system without the upfront cost and risk. So this system kind of provides that alternative. As I mentioned, we have a pair of redundant servers running in a data center in Calgary with SmartLayer IT solutions. And like this concept in itself is not new to SCADA, but there are a couple aspects of VTScada that are a particularly good fit for running this way. We offer hosted sites with several tiers. They're based on the required size of tags and screens required. And this system also provides the backbone for our IoT offerings, which we are currently developing and expanding.
Nice.
And we generally connect, or we can offer secure private cellular connections to sites, but the connection possibilities are really endless in this application. So for us, we weren't trying to become a solely cloud-based like SCADA system provider. We were looking at this more of as a try before you buy stepping stone for companies on their way to their own SCADA systems. You guys mentioned VTScada Lite, and it's a great trial option and powerful tool, but it is quite limited in or has limits. So this is kind of an intermediate solution for a lot of our clients. What it offers is zero risk system expansion. Since SCADA systems tend to expand almost perpetually, I found that as companies grow and find more uses for the system, they can expand as this happens. And this way they don't need to predict where they're going when they're starting out. The cost they pay reflects their current usage instead of like a future estimated expansion case. And it's one of the big benefits of cloud computing is it's easy to allocate more resources to host servers as it's necessary. It also offers some deployment flexibility for projects. We've had large or projects with incremental construction where they needed SCADA systems now, but didn't have the physical location to put their servers. And this allows them to get up and running quickly, and then they can move on to their own equipment once it's built or installed.
Interesting.
It also opens the door for a wide breadth of industries that are slightly more non-traditional SCADA users, or at least industries we didn't have exposure to before.
Right. So I'm curious, you talk about moving people from having the cloud system be the thin edge of the wedge, and then having them move to their own freestanding SCADA. Do you have an intermediary or a blended kind of system where you have like a redundancy set up between a local server and the cloud?
Yes, we do have some clients that have been utilizing that as they're on their journey to their own SCADA system, where we have a couple like independent hosted applications that can then sync between our cloud servers and their local servers.
Right.
And they could run this way perpetually as a cloud backup option if that's what they wanted, or eventually cut the tie and move to their own system entirely.
That's kind of the best of both worlds.
Totally. So due to the flexibility of the system, there's also a couple of uses that we didn't entirely foresee, such as temporary sites, particularly for measurement, metering, compliance type problems.
Right.
Regulated industries that are on fixed budgets that don't have access to capital spending as easily, and also equipment rental companies. Since the subscription SCADA cost can be fit in with their rental fees, and then they can expand and contract their SCADA charges along with the utilization of their rental fleets. So we have a couple of these equipment packages working on our system in oil and gas, and kind of have 5 or 10 fluctuating clients right now in different stages, rentals, one-off metering sites, as well as we have a fish hatchery, rural water treatment, and even a brewery for remote monitoring and control of their beer fermentation. Next slide, please. So the VTScada platform has a couple key features that make this work really well for us. First is the realm filtering concept, so that we can have clients within a shared application that can only access their own data and sites. The biggest thing is the ease of configuration. Since we can utilize so much of the built-in functionality of the system, we can spend more time tailoring to individual clients' needs, and this allows us to give them the same purpose-built feel and implementation they would get in their own solely owned system, which is particularly important if they're intending to expand that way anyway.
Right.
And then lastly is the thin client, which really allows users to access the system anywhere without any software required or dedicated computers. So then for clients that are growing and expanding, the system offers the flexibility and time to get to know the features and then grow efficiently and organically. So they can add their initial sites and become familiar with the alarming, trending, security, etc., and expand this to additional sites. And when at this point they can really expand their usership and see how this fits within their companies and how they're going to utilize the new data they have access to. And then take advantage of some of the more advanced features of the system, like alarm notifications, customized reports, and we have clients using ODBC into OPC connections for further data analysis as well. And then there's always the opportunity to take a step back or reduce site costs if that is necessary. Next slide. So then for clients, as their systems grow, they can move from hosted sites into the independent application that we discussed before, which gives them a chance to set up their own equipment, purchase software, sync everything back to the cloud, and then eventually cut the tie and become their own fully owned and operating SCADA system that's already familiar. It's tested and proven, as well as this whole transition happens with no loss of historical data or interruption. I believe that is it for me.
Great.
You can find more information on our website. And yeah, this is really a solution that we can tailor for whatever a company could need.
That's great. Thanks for that. It's really nice to hear people talk about, things like realm area filtering are not the sexiest of of features. So we as VTScada people don't nearly talk about them enough. But in a hosted environment, that's really where the rubber meets the road. Being able to programmatically keep everyone's data and screens and everything just separate. So I'm glad to hear that was one of the things. Was there anything in the production of this? Was there any sort of surprise benefits that you didn't see coming?
Yeah, I would say some of the alarm notification particularly was one thing that VTScada has, obviously, but we weren't expecting to be utilized as heavily by our clients, to have a call-out system kind of rolled into their SCADA automatically.
Right.
Surprisingly useful to people. And, reporting as well, like some of those features are
excellent. Well, thank you, Brandon. I appreciate you coming on and joining us today.
Great. Thank you very much.
All right. Have a great day.
Yep, you too.
Okay. All right. Next up, we have Ben Baudouin, my English mouth, forgive me, joining us from Made Labs. Hi, are you there, Ben?
Yes, I'm there. You hear me?
I can hear you just great. So how's the weather there? Where are you right now?
I'm in Quebec, about 50 miles east of Montreal. So it's a small town, nice small town, perfect size.
Excellent. And so today you're going to talk about how to increase efficiency for lift stations. So I think I get the impression that, well, obviously with the economy being what it is right now, that jobs are becoming more endangered. There's higher unemployment, and this is going to have a direct influence on our tax base. So I think today you're going to talk to us about different strategies to help utilities cope with that scarcity going forward.
Definitely, because any thing that you can do that will help in reducing the cost of operating your collection system will definitely help the budget. And that's basically the idea of the presentation here, how you can do that. And one way is definitely to increase the efficiency of the pumps in the lift stations, and at the same time lower the problem that you might have at these lift stations.
Excellent.
So I guess let's start with this presentation. If we go straight to the next one. So I don't know if you got the most recent one, probably not. So I'll go to the next slide. I might make you jump faster to other ones because I know that time is short. Yes, go to the next one. Okay, first thing is when you have a flow calculation, when you find errors in the result that you're getting, at some point you can use these abnormal results that you're getting to find problems. Since 1989, I had analyzed thousands of lift stations, and I can tell you that 1/3 of lift station has abnormal behaviors that happen often and every day that people are not aware of. And these are causing problems in flow calculation. So if you have an algorithm that the one you just saw that can detect these abnormal behaviors, then you're able to react to it. Okay, so this is the fastest way to find problems before they degenerate to catastrophic event. So if you go to the next one, This is just a pure, next one after that. Okay, and if you click next, you will probably see all these abnormal behaviors that are going on that level. These came from a lift station that you would expect the pumps to start and stop at the same level all the time. You can see that the water, no way water works this way. I mean, you know that. But that lift station was connected to a SCADA system that was not reporting any kind of alarms, because it was never to the point where an alarm was long enough at a level that it was high or low enough to generate an alarm. So if your system cannot detect or see that these are abnormal, then what can you do? You will have to wait until it's catastrophic, and then you'll go there and maybe a pump will have burned by then. So if you go to the next one, here's another example. Just click next. You can see here that the water is going down without any pumps running. You know, it's not normal. And if you look at the 2/3, you can see that the pumps, by the way, on the top part of the graph, these are a pump run time and current. You can see at some point that they just start and stop all the time. These were 3 pumps starting and stopping every 8 seconds for many hours. Okay, so if you go to the next one, if you in your alarm system, if you manage to already preset these kind of abnormal behaviors, like also if the pump did not alternate like they used to, if the capacity of the pump has changed, if the efficiency of the pump, number of gallons pumped per watt of electricity have changed, or any kind of these things that you know are abnormal, if they do not generate an alarm, how can you react to it? Okay, so that's the main thing. So first thing is you need to get use your information to find what's going on in the lift station. Now that you know that, and after that, you know, here we have very short cycle. Once you have that, you're able to start to think about using a flow-based operating system for your lift station in order to increase the efficiency of that lift station. That's the next slide, I guess. So one thing I've done recently, analyzed 150 lift stations. My goal was to figure out if I have 1% of difference between my pump capacities, what's the variation that I have in runtime of these pumps? And as a rule of thumb, I can tell you for every 1% of difference in pump capacity, you have 2% of variation in runtime. This is true at 1%. This is true at 20%. Okay, so that means if you're able to increase the pump capacity by 10%, you will reduce the runtime, the maintenance, and the wear of all that equipment by 20%. Okay, so that's the main thing here. So if you go to the next slide. So the idea behind it is to increase the efficiency of pump station is very simple. Rise the level of operation of your pumps when it's safe to do so. Delay the start of an additional pump for as long as possible when it's safe to do so, and try not to pump into a pressurized pipe if at the same time as other pumps, if you can do that. Okay, and for that one you really need a good SCADA system to do it. So that's the basic behind it. If you click next, so typical lift station works this way. You have a lead level, a lag level, an off level. Usually they are relatively low in the lift station so that you can accumulate some water above it if you have a peak, and that's how they all work. I mean, 98% of the pump stations are working this way. So if you go to the next, and by the way, this gives you an average head, which is in the middle between the lead level and off level when you have only one pump operating. The idea is to try to increase or to lower that head, okay, as much as possible. So if you click next, so to use a flow-based operating system, you need to set what is a lowest safe level and what is the highest safe level. This is basically when the flow rate is very low, how high would you accept the level to be at? And when the flow rate is very high, you know, how low can it be? And what is a normal minimum runtime for your pump and a maximum runtime for your pumps before you would alternate between each other? So that's the idea behind it. So if you click next, so the idea here is to move the head higher, and if you click next, it will just move a little bit. The idea when the flow coming in is low, and historically it has been low at the time of the day, and there's no rain or anything like this. Basically, it's safe to run the pumps at a higher level than when the flow rate is high or when you don't know that flow rate. By changing the average head, this is how you're increasing your pump capacity, and by quite a lot. So, but you do that when it's safe to do so, and to know it's safe, you need to have real-time flow. If you click next, and again, if the flow coming in is high, and knowing the flow coming in real time, you know your pump will be running for 2 hours. If you're waiting to start them at the lead level, why waiting to get the lead level? I mean, as soon as you know that your pump will be running at least 2 minutes or a little bit more, start your pump right away. It will take way more time before you get the lag level where you start your second pump, and we know that 2 pumps together are not really very efficient. So if you click next, that's exactly what it's doing here. We lower the head, we increase the head in this case, but that's the idea behind it. And for variable speed pump, which is the next slide, it's a matter of just changing. Next slide, please.
1 minute.
Okay, for variable speed pumps, it's about the same thing. I mean, you're moving from the actual level that you're working at, and when the flow rate is low, you increase it. So, and that's what you see when you press next. It's just moving the head, and that's what you have to do for variable speed pumps. So if you click next again, okay, click next. Go on next slide after that. Of course, okay, this is the instrument that can be used to do everything I explained so far. And since we have a flow an analog output proportional to flow rate in real time, then you're able to give that to your PLC, and you can adjust your PLC so that when the flow rate is higher or lower than a certain value, then you adjust your levels based on that. But you need to have real-time flow for that, and that system do all the diagnostic that I was explaining at the beginning, and have all these algorithms built in, by the way. And we're talking about an instrument here that is only 6 inches wide, 4 inches high, and 2 inches thick. Next one. So click a bunch of next until the entire. Okay, if you take a print screen from that, you will be able to remember the link that you have on the bottom. Basically, what you have here, it's how you calculate the efficiency of a pump station, your own pump station. I made a spreadsheet for it, and you're able to just fill it up, and it will show you exactly what's the percentage that you can make of savings. If you click next, again, this is a place where we have 7 lift stations using this system. If you click next. Okay, next again. Okay, I want to see that red box on the right. Okay, on the right-hand side, what you see there, it's for these 7 lift stations, what's the actual difference in pump capacity that you got at each of these sites. The average was 17% in pump capacity by adjusting these levels. And at the end, that's 34% of savings that they will be making when the flow rate is actual. Well, there you go. This is to remind
me. That's me calling you.
No, this is me to remind me. I just did my 10 minutes. So in that case, you can see that the savings per lift station was from 10% to 23% in pump capacity. The increase, therefore, the variation in runtime is 20% to 46%. And,
that's great. Well, thank you, sir. You covered a lot of territory there. I appreciate that. So for those who want to get in touch, and for those who want to download that spreadsheet, that looks amazing. Here's how you can do it. You can go back in the live stream later and find it. And this is how you get in touch. And thank you very much for joining us today, and have a great day.
You too. Thank you very much for the invitation.
Our pleasure.
Okay, bye.
Now I should also mention, before we go to the prize winning, that we also have a set of breakout sessions. There's sort of two parts to this automation village idea. One of them you're looking at right now, and that's our virtual trade show. And the other part is our breakout sessions. So these, what you're watching now, are these very high level TED Talk kind of presentations where these virtual presenters have been doing an amazing job of coming in blind and offering content, but it's mostly one way. You can ask questions in the comments, but really where the second part of the loop is in our breakout sessions. And that means that you'll be able to attend one of several streams of different industries. You'll be able to listen to more in-depth demonstrations and presentations. And also you'll be able to ask direct questions and get direct answers, which is really what a trade show really comes down to. That's what makes it different than just about anything else. Anywho, getting back to forward compatible SCADA. So if you want to win a $100 online shopping voucher, please type in natasha.lutz@trihedral.com into your email, and in the top line, the reline, it is forward compatible SCADA, exactly like that, uppercase, 2 spaces, and send that off to Natasha, and we will draw a winner. All right. Now, so Dave, I just did a lot of talking there. Is there anything I missed?
No, I thought you covered actually a lot of the show pretty well. So, you mentioned the breakout sessions, and that's the chance for people to really get into their kind of deep dive as opposed to this more high level. So there's not always all the presenters that were in this show. It will be kind of a breakout, and there's sometimes we've had, I think, some presenter from a previous show come to a new one and so on. So it's sort of a little bit of a mixed bag, but you get in your utility stream typically. So if it's water, power, whatever. So, the breakout sessions can be really good because you can get a lot of information and get the expanded version of what's going on. So, right. Chris, we've got some more stuff coming up today. I think we've got some other prizes. I know we still have Barry Baker to speak. We say we've got a number of things coming up. So if you're just tuning in, then hang on. We've got a little bit left. Next up, I believe, is Mark Romers from Filter Magic. So, Chris, I will give you back the controls here to
Thank you very much.
Pull him up.
Excellent. So we should have Mark unmuted on the line. Hi, Mark. Are you there?
Yes, I am, Chris.
Excellent. Welcome today. How's the weather where you are?
Getting ready to pour down rain. Otherwise, a beautiful spring.
Excellent. Well, now, where are you?
Richmond, Virginia,
right.
right in a very beautiful part of the country.
Excellent. Well, thanks for joining us today. Now, how has the present business practices been affecting you, you and your employees having to work from home or work in largely empty offices? How's that affected how you do things?
Well, we're not traveling. We're certainly not getting on any aluminum tubes to go anywhere at the moment, but we are fortunate that we can still work within our business. We got plenty of room here for our employees to spread out and continue to work on systems that we're developing. We're getting ready to have our first virtual factory test for a very large project next week, and everyone's really having fun with all that technology necessarily to do that.
That's excellent. So before we begin, I think I had a note looking through your slides, and I wanted to make sure that I asked to tell us about zero to waste. I know that's something that's very important to you that you'd like to talk about.
Okay, well, Chris, before I jump on that, I'd like to thank you and thank VTScada, Trihedral, Patrick, Alan, Dave, Peter, and Natasha for hosting this great event. The zero to waste is an invention my first invention that I was granted about 1.5 years ago, and it was a natural extension of Filter Magic, where we wanted to do things better in filter systems than had ever been done before. And I'll talk about that more later as we get into the program itself, but It is an integral part of Filter Magic, and it provides gravity filter system control at unprecedented levels, where, as the name implies, the trade name, zero to waste, they do not waste any of this precious water in this world.
So tell us a little bit about the history of Filter Magic.
Well, my parent company, my original company's Industrial Control System. It wholly owns FilterMagic as a subsidiary. I've been in business for 40 years. We started with carbon paper and smoke signals back in 1980, and now look where we are. I've moved from being an integrator, and back around 2009, moved into being with FilterMagic, a filter control system manufacturer, a radical change from being an integrator to being a manufacturer. One thing is true throughout this entire period of time, and that is that water still runs downhill, and we're here to help save every bit of it that we can.
That's great.
So back in early 2020, and FilterMagic made an ultra critical decision to change its filter control console HMI interfaces from traditional, outdated, older OIT platforms to state-of-the-art industrial PCs powered by VTScada software. Next, please.
We actually have some lovely, thank you for putting this lovely waterfall in. I don't know if you can see that, but it certainly has been the calmest part of my day so far.
Well, we hope it works well on the screen. So you're showing at the moment that first screen that I've really covered everything is there. If you'd like to go to the next screen.
Great.
Take that water away from you. There we go. Okay, so FilterMagic, as a manufacturer of filter control systems, is a proven, patented, very innovative filter control system technology. Very innovative. We take complete responsibility for the entire filter system and for the water, especially for the water. Our comprehensive user-friendly software provides precise backwash control and optimizations. Our solutions are ideal for gravity filter systems, the water or the wastewater world. And at this time, we're selling these systems throughout the United States, but we're going international, at this very time. Next, please. Well, long ago, I met Patrick Cook, as I'm sure many of us have, in this webinar. I met him in a booth at a conference somewhere in the country, and over many years and many conferences, Patrick and I became friends. Throughout that period of time, we both traded stories about each other's products. And after learning a lot about FilterMagic, one day Patrick told me that VTScada could handle 1 million tags. And at the time I said, who cares? We hadn't seen systems that needed more than 5,000 or 10,000 tags. So who cared about 1 million? But over time, and I did appreciate all those tags. What I really appreciated was every time I saw them, there were more and more, an unending number of user-friendly features that the VTScada software provides. And as I came to have a better understanding of the power of VTScada, I came to believe that this high-performance software, coupled with high-performance industrial PCs, was exactly what FilterMagic needed to continue to provide its client base unprecedented cutting-edge filter control and backwash optimization solutions. Now, not to leave Alan Hudson out, but I've known Alan. I've known Alan for over 30 years, way back to the Bristol days, if you will. And there we were 30 years ago down in Jacksonville, Florida. And we were both working with the same client. I think it was United Water at the time. And we didn't have anything to do one evening since we were both in town there. So we decided to go to a movie theater locally, and we watched the opening of Saving Private Ryan together. And that's been a laugh between us ever since. But it's important to note that we did share a box of popcorn, but we did not hold hands. Okay, there you go, Alan, from me to you. So next slide, please. Oh, I'm sorry. Okay, so what we're looking at here, I'm sorry, go back one slide, please. We're looking at an older screen that covers 8 filters. It's a summary screen that we use, and this was done, in Rockwell software through an OIT, and it's very challenging to develop all this, and very limited features, and we really needed to find more capability, and that became industrial PCs and VTScada. Next slide, please. And so what we see here is 11 filters on a system that we're getting ready to conduct our virtual factory test on next week. It's a large, complex, multi-plant system. One of the things that's so important about all of this is the ease of using and the unlimited capabilities of VTScada. We did the 3rd plant and replicated it with all the gadgets and widgets and whatever you call those things in less than 1 week as we built the models of all the software that we want to use. So all the features are kind of ticked out here. I won't go all of those, but one of the biggest ones is the power of VTScada coupled with historical data and trending. Next slide, please. Well, I tell you what, let's go back 2 slides real quick.
Sure. Boom, boom.
I was going to talk about redundancy.
I was going to ask you a question too. I apologize.
That's all right. It's right there, and I knew that. But the redundancy, we have a nickname for an operator called Operator Loco, and we had made a decision long before that providing the spare parts necessarily Filter Magic, we didn't want to provide OITs or industrial PCs as spare parts because they're obsolete by the time you take them out of the box. So in an effort to make the system more redundant, we worked with this particular software, but it takes the same number of screens for all filters in all 8 locations. It's terribly cumbersome and hard to do, but we made it fully redundant so that if Operator Loco with a hammer runs through the filter gallery, taking out every OIT, if you tackle them while one is left up and running, you can still run the entire system. Next screen, please. Can we move to the next? There you go. So what we're looking at here, this whole opportunity for redundancy is so easy to do, and that would be on the previous screen, but okay. The bottom line is that every industrial PC is a server that's primarily running the entire filter control system. And so if we lose that particular primary PC with VTScada on it, then it moves to the next one, so on and so forth. And every industrial PC is there with the complete history, trending, and functionality. So easy to use. Now, what you're looking at on this particular screen is an older graphic screen and a newer graphic screen, and you can see the high performance graphics, ease of use. It's obvious. Let's go to the next screen, save some time. Okay, what we're seeing here is what's so powerful, and that is to have all that data at your fingertips at the console to be able to find these very useful trends and necessary to perfect how you operate filter systems and how you perform backwashes so that you don't waste any water. This is where the power of zero to waste comes out and can be implemented, and it's so easy for clients to perfect their backwashes. Let's be clear, backwashes across the country average 10, 12, or 15 minutes in duration, when in reality, we know through the science of everything we've proven, we can get them under 5 minutes, saving clients hundreds of millions of gallons of water annually, year over year. It's every drop counts. We don't want to waste that water. Next slide, please. I think I'm getting down to the bottom of my production here, one way or the other. I hope I've been finding useful information, but I would like to say that we're proud to partner with VTScada, developing these unprecedented filter system solutions. You've already talked about the Automation Village breakout in a couple of weeks. I'm looking forward to being a part of that and providing even more information about what we do, and we hope that you'll join us. Chris, I want to thank you for hosting this today, and I think I'm done.
Well, I just have a quick question before I let you go, Mark. Thank you for that. That was a great presentation, and I'm just enjoying your water again. So I just wanted to go back, something I had sort of hoped to ask you earlier, which was, so you're talking about this really great idea, which is replacing OITs, which is sort of a single-purpose HMI, with something that can really act as a SCADA node, a full SCADA node. Tell us about the other advantages that come from, like, for example, again, getting back to redundancy, that come from using a SCADA system as a replacement for OITs.
Well, as I spoke earlier and tried to describe, we were a little off on the slideshow, but if we have 11 filters, we can go to 20. It's almost unlimited what we can do. But each industrial PC with VTScada on it, it can act as a master, and one of them is acting as the master, and it's polling all 15 or 20 that they are, and it's got all this data available at all 20 at one time, but one's in control. And if we lose that one, it inherently switches to the next industrial PC VTScada and continues to provide all that same information And this is nothing but a cut and paste process. This is so easy to do through the VTScada tools, but it provides unlimited power and redundancy to the client.
That's great. Thank you for going back on that. That's something that, again, we don't ourselves talk about nearly enough in terms of that different way to look at a system. So thanks again today. That was a great presentation, and we enjoyed having you, Mark.
Well, Chris, I enjoyed being a part of it, and we look forward to the next opportunity. Thank you, sir.
Excellent.
Have a good day.
You too. And of course, you can see filtermagic.com is the website to go to. Also, you can find that address in the description of the live stream. Please go and have a look. So moving on. Next up, we have David Epsey, who I have on the line. And David is talking to us today from ICS Cyber Concepts. Hi, David. How are you?
Good. I'm with Jacobs here.
Oh, yeah. Sorry, I had notes and I was listening to something on my headset. Thanks for joining us. Where are you today?
I'm in Denver, Colorado.
Oh, excellent. We were there at ACE just a year or so ago. How's the weather?
Weather is beautiful today.
Excellent.
Nice.
So today we're going to talk about basically balancing the needs of ease of use versus effective security. Is that a fair description of what we're going to talk about today?
Yeah. Basically, applying security in a way that's understandable and easy to do. Yeah.
Excellent. Well, why don't I just let you carry on there? Move on to your first slide.
All right. So I'm Dave Espy with Jacobs Engineering. We're one of the largest engineering firms in the world, second to AECOM. And a little known fact is Jacobs is one of the largest integrators in the United States. And we do it all. We engineer systems, engineer and design. We implement systems, and we actually operate ICS systems. So we know what impacts bad engineering and design can have on the operations. So my group is called Operational Technology Services. I'm the founding member of that group and act as its deputy director and lead the engineering and design portion of that group. Next slide, please. So our knowledge goals start with the human factor to cybersecurity. People don't realize that the human factor is about 80% of a cybersecurity posture. And you can think of things like sticky notes with passwords on them. How do people manage their passwords? How do they manage information about the system? How do they interact with the system? That's the human factor. So we'll talk a little bit about that. And then the benefits of network segmentation. It's a really critical method to improve cybersecurity. And then we'll talk a little bit about remote access. Next slide, please. So you guys might remember the false missile alert in Hawaii, where they sounded the alarm of a North Korean missile coming in. Well, that wasn't their only snafu that day. They actually had this video clip with their passwords to their system on a Post-it note. And there's a lot of other information that you can glean off this picture too, as well, like their operating system. So the point of this picture is to spur thought around how are we managing critical data about our system, whether that be a password or the operating system or the hardware we're using. What about information that's publicly available, like in RFPs? How much can I tell about your system in the RFPs that are on the street? We've got to be careful about what information we allow out into the public. So this is the human factor right here is very apparent. Next slide. And then this is another human factor, phishing. That's one of the #1 ways that systems are compromised. And if you look at this one, I mean, if I wasn't a cybersecurity guy, I'd probably click on view photos. Like, who's posted in my Google Photos? I got to see what's going on here. Very sophisticated phishing schemes can involve emails that look like they're from your boss. So one of the ways to mitigate this type of human factor risk is make sure that you have ICS specific cybersecurity awareness training and training folks what to look for in phishing schemes. And like I said, this is the number one way that systems are infiltrated is phishing. And we can talk a little bit about that a little later in our presentation, our short presentation here today, and then a lot more about it in our breakout session. Next slide, please. So let's talk about network segregation for a little bit. So you might see the quote here from NIST Special Publication 800-82, and that publication is the Guide to Industrial Control System Security. And we use this publication a lot because a lot of our work is in the water sector, which doesn't really have cybersecurity regulation. However, if it does, and when it does, it will be based on NIST guidelines and documentation. So we kind of use this as a basis for our designs in the water sector. But you can see the comment here that network segmentation and segregation is one of the most effective architectural concepts that an organization can implement to protect its ICS. So what does that mean? Well, there's two different things here, segregation and segmentation. So segregation is the different security zones you see here, in that your ICS zone is completely segregated from your corporate and anything else, internet, whatever it may be, via firewalls. And you have a DMZ, and you guys might be familiar with the Purdue model, which is a similar concept, but it does have that 3.5 layer, that DMZ there, which is critical in segmentation and talking across zones. Next slide, please. So we'll get a little deeper into that concept. This other NIST quote here says that the ICS should be segregated or separated on physically separate network devices. So what does that mean? That means you don't want to share this layer 2 switch down here that's in the green security zone, your ICS security zone, with anything on the corporate network. A lot of folks, they virtually segment via VLANs, and they think that's adequate security. And this concept here is defense in depth. You don't want to share physical resources with another security zone. So now we drop down into segmentation. So inside each security zone, you can segment the network, and you can see the VLANs applied there, the supervisory network, the control network, and that helps isolate broadcast traffic. It helps isolate your PLC and control traffic from any other traffic. So you can apply these concepts that really improve and layer on security. And as you can see, the other quote here in the NIST documentation is, a single, if possible, connection be allowed if you have to talk to any other security zone, so that in a pinch, you could go pull that connection and be disconnected. And you can see that in the architecture shown here. Next slide, please. So let's talk about remote access a little bit. And we'll get into these concepts a lot more in our breakout session. But this architecture shows a fairly secure remote access. And I mentioned we were going to revisit phishing. So you'll notice at the top here, we've got a firewall, and people are going to VPN into the firewall to get remote access. Now, if you remember the Ukraine power grid attack, they used a phishing scheme to get legitimate credentials from a real user of the system. They VPN'd into the system as designed, and they controlled the system, used the HMI as designed, turned off the breakers, and then they bricked the UPS so they couldn't bring the system back online and control it again. And they did that because there was no two-factor authentication. So that's a very critical thing nowadays. That's a must. If you have any kind of remote access, is to have multi-factor authentication at your VPN for sure. If you drop down into the DMZ security zone, you see that we have a privileged access management solution shown here. And we'll get into that concept a little more in our breakout session. However, the key concept is that it's brokering the session. You're never directly connected from your engineer vendor laptop directly into your SCADA zone. You never allow that direct connection. It's always brokered through the DMZ. And the way the NIST documentation reads is should be separate ports. So you see there that on the top we've got port 443, HTTPS, and then on the bottom, in this case, it's RDP. And it's totally disparate ports. And the remote connection is only to allow access to a trusted workstation. In this case, if it's an engineering workstation, you have that trusted workstation down there, you're doing all your programming, and all your files are on that workstation, so you're never bringing in external files. Now there's secure methods to do that if you need to do that, which we can talk about in our breakout session. However, the principle here is that you're always working on that trusted workstation and never have any outside connectivity. And that about wraps up our quick session here. We'll have a lot more information in our breakout section.
About 30 seconds. Oh, that's pretty much it.
Yeah.
Are you still there?
Yeah, I'm here.
Oh, hi. Yeah, thanks. That was a really great, I enjoyed that presentation. So many things to think about. That picture of the password on the monitor haunts me. So I have a couple of questions if you have a moment.
Sure.
So you talked about different tests that you can run to help people become more familiar with phishing techniques so they can become more resilient. Is there any way to look at a way to encourage employees to look at their workstations, or to look at their fridge doors and spot those kinds of errors?
Yeah, definitely. And the way you do that is to employ ICS specific cybersecurity awareness training. Right. And you can get that several ways. There's vendors that have ICS specific training. SANS is one of them, Securing the Human. They have a module that's ICS specific. You can also get free training through the DHS ICS cert, virtual online training, right. Which is good. You can have there's a 1 hour session that's really great for anybody that's even interacting, from the receptionist on up with an ICS, and it gives them basic cybersecurity awareness training. And then there's a 10-hour session that's 10 1-hour increments. That's right. Really good for people that are actually administrating the system. But yeah, that's really the key, is making sure that it's focused on ICS cybersecurity, and it'll focus on those types of phishing techniques used in that industry.
The other thing that and I guess we all do is, as people get better at cracking passwords, the safety of the password when it's reliable becomes just a gong show for regular humans to try to use and manage. So what are some of the strategies that, I know this might be included in that training that you talk about, but give us a few examples of how people are managing that password complexity.
We recommend using, and DHS recommends using passphrases if you have to use a password. They're longer, they're easier to remember. The other method is if you move to multi-factor authentication down at the workstation level, sometimes it's a lot easier for the operators to remember a PIN rather than a password. They can have their token that they put in the number, and then they just have to remember the PIN, and then they're done. So it's a lot easier for operators in that respect.
What about biometric solutions? Yeah,
those are available as well. Sometimes you have issues with biometric solutions, so you have to have backup methods of getting in the system, especially in an operations environment, some break glass accounts or something like that. But yeah, biometrics are employed in several of our clients. And like I said, if somebody is using a thumbprint or something and they mess up their finger, well, that's not going to work anymore. So you've got to alternate means. Yeah. Yeah.
So what's the next step when people are interested in, when people have sort of identified that they're in danger of being the guy in the Hawaiian shirt? What's the first thing they should do?
Well, before you go on camera, you should check your environment, right? Pull down the post-it.
I guess we should all get up and do a 360 in our living rooms, because we probably have passwords posted everywhere right now.
Right. Yeah.
Well, that's great. So and now you're going to present more of this at the breakout session.
Yeah.
So what can we look forward to there?
More of the same, and then we'll get into more cybersecurity concepts on the technical side as well. We'll cover the human factor, but we'll also get into the technical side and just basic cybersecurity practice, good architecture for ICS.
That's great. So people can find more information on your website, and that's listed down in the description for the live stream, and so we encourage everybody to do that. And hopefully you'll stick around and maybe be in the comments section if anybody has any questions.
Sure, no problem.
Excellent. Well, thanks, Dave. We look forward to those breakout sessions.
All right, thank you.
And thanks for joining us today.
Cool. So next up, we're going to jump to a quick video, and Chris and I will talk.
Anyone who's listening, just
All right,
hum your favorite
we're
tune
back.
quietly. Here we are. Thanks,
So,
thanks, Natasha.
Apologize for that. The audio did go out while that VTScada Fest video was playing there.
Of course.
So I guess just to sum it up, what you saw in that video was VTScada Fest last year with a time lapse and some photos and stuff going through. We showed some things like the presentation room. So you saw one of the presentation rooms being set up there. We had our developers den. We had all kinds of different sort of breakouts and challenges and other things going on. So there's a lot of different events for really a very wide variety of people. We also gave out some awards for some of our system integrators and other things during the event. Chris, did you have anything to add to that?
Just that this was, again, it was a big jump. We've grown every year that we've done it. Natasha Lutz, who you've been writing emails to in hopes of winning money, she's been working really hard to make sure each year is a big build on the last. This room was a great example. When we played the rock and roll with the huge sound system and the rock and roll lights, I know Brian Sinclair's never looked happier when I've seen it.
Yeah, there was one in there with Brian and his put his shirt open at one of our social events there.
So I guess that's a good time. Another reason why, one of the reasons why VTScada Fest has grown every year is this gentleman, Barry Baker. He's the vice president of VTScada by Trihedral. He should be on the line right now. Let me just make sure I allow him to talk. And we're going to give Barry the last word. So before we go, first of all, hi, Barry.
Hi, Chris.
Hi, thanks for joining us. Before we let you go, I just want to thank personally all of the presenters who joined us today. It is a real leap of faith to put yourself and your message in our hands. So we thank all of them for doing that. That was really brave, and they all did a really excellent job. And now, would you like to any other closing remarks before we hand it off to Barry, who will close this show and drop the mic for us?
Thanks, Chris. I'm impressed to see such a great show being produced while dealing with the challenge of being socially distanced. It is said that adversity gives rise to new methods for greater efficiencies than otherwise would have occurred. I think we may be on the cusp of new work methods. Next slide, Chris. That put the virtual trade show together, whom are all working remotely, and the challenges that brings. It's quite complex to coordinate all that is happening behind the scenes, and a few late nights were required to pull it all off. Fortunately for us, we're a company that is adaptable to be able to work remotely with little or no impact to our business and our day-to-day operations, whether that is R&D support or even our sales group. It's hard to follow after Alan and Pat, but I'll do my best. Next slide, Chris. We also need to give a real special thanks to the virtual exhibitors for their support and contributing their valuable time. I greatly enjoyed the presentations and diversity of their expert knowledge that we saw demonstrated today. We consider ourselves lucky to be a company that we can really work cooperatively with so many industry leaders in support of our mutual customers. We're not competitors. We work together for the greater benefit of our customers, which they enjoy. And as always, your feedback is always encouraged to improve things among our exhibitors and ourselves. Next slide, please, Chris. We'd like to make people aware of a few related upcoming events, as we mentioned earlier. The Automation Village breakout sessions, they'll be featuring many exhibitors presenting today. We'll do a deeper dive on topics spanning multiple industries. This is our second event. Will be on Thursday, May 7th from 11 a.m. to 2 p.m. Be sure to register and attend. Again, we really enjoy putting these on and sort of delivering knowledge to our customers and working cooperatively with others. Chris, next slide, please. Right, and there'll be a trade show number 3. Will feature a new group of industry-leading experts. Again, more topics from the automotive industry. This will be on Thursday, May 14th, from 10 to 1 a.m. Again, please attend and continue this journey of knowledge and learning and helping each other. Chris, next slide, please. Right. And we'd also like you to subscribe to our YouTube channel and keep an eye on our website, LinkedIn, Twitter, and Facebook for more details about upcoming events. That way you'll be alerted as much time as possible and be able to schedule your time appropriately. And Chris, last slide, or second last slide actually. And also please note that you can visit our website at any time to download our VTScada Lite version. It's the same product as our core offering. We're a one-product, pure-purpose company, so it's just limited I/O for small systems. We're pretty sure once you try it, you'll want to expand its use. And Chris, last slide. And final thank you, last but not least, is thank you for taking the time to watch. Stay safe, and we hope to see you at the next time. Goodbye.